Hey everyone, welcome to Simplilearn. Today we will learn SQL Full Course. The demand for data analysts continues to rise across industries. It's a field that blends creativity with logic, allowing individuals to uncover meaningful insights from raw data. For learners, it provides the perfect platform to combine technical skills like SQL, programming, and data visualization with problem solving and business acumen. To become a data analyst, start by learning foundational tools like Excel, SQL, and Python for data manipulation. So today we bring you the SQL Full Course. In this full course, we'll explore how to query, filter, join, and manage data using SQL. By the end, you will be confident writing powerful queries by databases across any domain. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for a quick info, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or grow in your career, then you must explore Simplilearn's code of various data science and data analytics programs. Simplilearn offers various certification and postgraduate programs. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, Excel, machine learning, data visualization, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into a data science or data analytics role as a fresher or moved on to a higher paying job and profile. If you are interested in making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your experience and areas of interest. Now, without further delay, let's get started.
In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access.
Today we will learn SQL Basics. SQL is the spine of data analytics, whether you are trying to store decades old of data or retrieve a row from racks of relational databases capable to store petabytes of data. SQL is always your best tool. So in today's session, we will learn the basics of SQL through a small use case. So here is the context. Imagine you're a SQL developer, and as a SQL developer, you face a critical issue during the project. Your client runs a huge restaurant and now is eager to expand his franchise. He has a couple of questions, and these are real business questions through which he can understand the performance insights, like the best selling products and increasing their inventory, offering memberships and discounts to frequent customers, and much more. This would automatically help the client to reach greater heights in business. Now, let's switch to the MySQL workbench. Now we are on MySQL workbench. Now we've already created a database. So let's start with use database name, which is SLP. Use the Control Enter shortcut to access your database. Just in case if you haven't created your database, just go to the schema section, right click, should look something like this. Here, you can create a new schema. Create schema, and you can name the schema and proceed. Let's say sample, and then select apply. And here you can check some other priorities or parameters. Let's say if you want to lock it, you can. But now let's proceed with the basic default one. Apply, and a new schema has been successfully created. Now you can close this one, and let's say you don't want a schema, then you can go to these schemas here, and let's say I don't want car dealerships, you can just delete the schema by pressing drop schema. Now that we have a brief understanding of how schema works, now let's proceed with creating data tables and loading data into it. So there are multiple ways. Let's say you want to create by manually typing in the code. You can do that. Let's proceed with that one first. Now, our tables are a little bit too long. We'll be using 5 different tables here. So, to create any table, basic priorities are you need to use the keywords create and table, and after that, the customized name for your table, and followed by that, the column names that you want to have in your data table, along with their data type. So, user ID will be integer data type, and create date will be data type, and product ID will be int. Similarly, to insert the data, you need to use the insert keyword and into keyword. Now you need to provide the specific table that you have created here. So you have created sales table. So you have already added the sales table name here and the columns user ID, created date, and product date, which are over here. And next, the values. You need to enclose the entries in parentheses. So integer will not have any specific single quotes or double quotes. But if you are adding any data which is character based or date based, time based, then you need to encode that within single quotes. And after that, the product ID. Now we will have a separate table for product as well. Remember, by the end of all your entries, provide a semicolon which indicates that is the end of all the entries for your data table. Similarly, we have also provided a semicolon here, which is telling SQL Workbench that it is the end of creation of a data table. And these entries or these column names are enclosed within parentheses. Now here we have a product table with similar entries or columns and also similar entries following the priority or parameters, which will include insert into and values keywords, and also the column names which you created, and so on. So these will be our data tables. Now let's quickly run all these commands and create the data table. There you go. The table has been successfully created and the entries are also inserted. There's a small mistake at row 1. If you go to row 1, let's check what might be the issue. So the problem is with the date value. So SQL Workbench follows the date value, which is year, month, and date. So here, while I was writing the dates, I entered date, month, and year. So we just need to correct it. So now that I have corrected, let's try to run it once again and see if it works or not. There you go, it works. Now let's proceed with creating the product table. It's created, and also the product menu. Followed by that, we have user data. And when it comes to users data, we have two different users data. So one is regular users, so including all the users from day one. So out of all the users, a couple of users, if let's say if we have about 10 users, a couple of 5 or 6 users preferred to take golden membership, or let's say in our perspective, the customer or the owner identified these customers to be most valued customers, or they are the ones which frequently visit the restaurant and order good bills and etc, right? So he kind of sells them premium golden users sign up. So here it is. So they buy the golden user sign up. So now let's proceed with that. And here you can see I've got the data corrected for this one as well. So we have created the table users. Now let's enter the data for users. There you go. The data has been entered to users. And now we will also create users names data table, which will have the details of users, and enter the details. And lastly, a few of those users who chose to buy the golden users sign up, or being offered by the client or the restaurant owner, right? Enter. And last table, the entries for these data table. Now these were the data tables. Now let's also validate or fetch the data. So we have about 5 data tables, right? So let's mention them here. 1, 2, the rest. So these are the data tables. For fetching the data, you need to use the select command and star for selecting all the columns. But let's say if you had a specific column to extract, then you can mention that specific column name from data table, right? Now I want all the data columns. So select star from table name and semicolon to make sure that the SQL Workbench understands that is the end of your command. Let me provide the same command for all the tables. There you go. Let us run. So these are the entries. Similarly, next one, these are the entries. There you go. Fourth table. And lastly, the fifth table. Now, you understood how long it is. But let's say you already have all these data tables existing as a SQL, or let's not consider SQL database. Let's say we have this information in Excel table. Then what you can do is you can just directly extract that data, right? So what you can do is just recently we created a sample database, right? Let's try here itself. So we have, let's say we'll go with car dealership data as well. And here you have the tables. Just right click, and here you got the option import data wizard, table data import wizard. And now you need to just provide the location of the data. So I'll have some Excel sheets somewhere. Let's go with Excel datasets, and I have some customer data here, and I'll open it. And now you go to next and next. There you go. It will give you the information. It will let you decide the data type as well. So I'm currently okay with all the data types. For row ID, I'll go with int, order ID, text, order date. If you want to change, you can go into the data table options and provide date time, right? So, we also have ship date. You go with the date time option for this as well. Order date and ship date, ship mode, and so on. Check all the other columns. There should be a delivery date as well. I think we already made that. And it also assumed that it will go with double for price, discount, and all other options where you might have decimal inclusions, right? So you can either go with float or double is also good. There you go. Now you just need to check on next, import data table. Okay, you need to press on next. It will start preparing import and imported file. Click on next again and finish. Now if you click on tables, you can see your customer data table is readily available here. All the columns, if you press on column, let me expand this a little. So all the columns you're looking for, order date, state, region, everything, it is readily available for you, right? So these are the easier ways to either create the data or import the data for your SQL workbench. Now, let's proceed with solving the questions. Let me change the orientation. Let us go with this one. There you go. And let us also expand or increase the font size for the better visibility of code. Now, let's proceed with all the questions. We have about 15 to 20 questions. And here you can see I've used this particular symbol to make sure that SQL Workbench understands that this is a comment. Right? You can write comments in both the ways. You can choose to just double hyphen or slash star and another star and slash. This will make it a comment. Now let's proceed with answering the questions. What is the total sales revenue generated by each product? Now the question was, what is the total sales revenue generated by each product? Now he wants to identify the total number of products available in his inventory, and he wants to sum up the total number of orders received and sum the price according to the orders received. Let's say he have about 5 items in the menu and each item got about 2 to 3 orders and into the price, and he wants to know the profit. So for that we might have to join two different tables. So the product details are in the product table and the sales details or the price details are available in the sales table. Now we will select product name. So I've recognized product table as P here. So what this will do is it will act as an alias to product table name, and it is specifying SQL to understand to avoid ambiguity and go to the product name which is available only in the product table. And here we are using the summation operation as the aggregate operation to sum the total price, and it has been aliased as total sales revenue. So you can alias the resultant column name using the keyword as, and you can give a customized name. In our case, I gave it total sales revenue from sales data table, and I've aliased it as simple letter S. And coming into join operations, we are performing a simple join operation here to product table and the sales table based on the common column between both the tables, which is the product ID, and we are grouping by product name. Now let's run this and see the output. There you go. And in case if you wanted to order it by increasing order, right, highest one on the top, then you can also use order by product name, not product name, sum of price, or you can use the alias name as well. Rerun it. So by default it will take ascending order, so we need to provide descending. Now you have these items which were on the highest sale. So these are the products which gave him the highest number of orders and highest profit. So he needs to focus on improving inventory for these products. Now let's switch to question number 2, which is which 3 products have the highest sales revenue? In talks we already solved this question. So order by, what you can do is he's just asking about the 3 products, right? So we can give him the result of only 3 products. For that you just have to paste the same code, enter limit 3. Now what this will do is it will yield in result with only 3 rows. So you'll get only these 3 entries as a result. There you go. So he needs to focus on these products. So how many users have signed up for the service and has taken the gold membership? Now let's try to solve this one step at a time. So there are 2 ways to do this. Basically you can just count the number of user entries from the golden users sign up table, or the other way around. Now he wants to understand out of the total number of customers, maybe around 10 to 15, he wants to know the ones which have taken the subscription. So let's go with the second approach, where we'll try to combine both users table as well as golden users table, and we will specifically match the user IDs which are in both golden users table and users table. Basically, let's say there are 2 approaches. You enter the restaurant today, you like the food, and you like to take up, you like to become a user of that customer but you straight away go to, the golden user membership. Some rich people do that, right? And the other way is you might be just a common user, then you just like the food over and over, and then you turn out to like it a lot that you prefer becoming a golden member, right? So there are two types of approaches. Now let's count both of them and try to solve it. So what you will do is, we don't want, let's say if you want to count the user ID from golden user sign up, there might be entries where user ID 1, which is a golden user ID, might have, appeared multiple times in a row. So you don't want to count that multiple times. You just want to count the distinct ones. So once if you counted the number 1 or user ID 1, you'll leave it if it is repeated. So we will be using the distinct keyword here and count aggregate function, and you will alias the name of the column as gold members from golden user sign up, and you will join users table and you will alias users table with an alphabet U on golden users ID is equals to users ID. Now let's run this command. There you go. And the count tells us 5 entries are there in the golden members. Now let's proceed with the next question, which says what is the revenue generated from gold users. Now you need to kind of join tables here with golden users data table as well as sales and users. So you have 3 tables basically. So you need to identify golden users, identify their user IDs, and you need to match every order which was placed by golden user IDs, and also the product. Yeah, you also need to join the product as well. So product is the table where you have the details of the product which are being ordered by the customers, and you need to also check the price which is available in the sales table. You need to join all these 3 tables and sum up all the pricings for the orders they placed and give the total number of revenue they generated. Now let's deal with this. We have the analogy in our mind. Now let's write the code. So here I have selected the price as well as we are performing some joins with golden users, product, etc. Right? So using the aggregation function, which is sum, to calculate the total pricings these particular users prepared or bought from the restaurant, and we are aliasing this particular column as gold users revenue from sales table. Now we are performing a simple join on golden users sign up as well as users table, and also the product table which has the product details. Now let's run this particular command. So overall, the golden card or golden sign up customers gave about $4,690 of revenue to this particular restaurant. Now proceeding with the 5th question, what is the total revenue generated from gold users? I think the question is repeated here, not to worry. Let's proceed with the next question, which says which users have been a gold user for how much of time? Now this particular question is a little bit tricky. So he's asking about the users which were actually regular users before, and on timely basis down the line they converted into gold users. So how much of time, right? Which users have been a gold user for how much of time? So you need to evaluate the users first and then identify on what date they were registered and what date they became a golden user, and so far how much time they have spent being a gold user, right? So let's start to write the query for this. So there you go. We're selecting the user ID column for golden users table. So we have aliased it with G alphabet, as well as we're using current date function and date def function. So we are trying to subtract the sign up date. If you check the data table of golden users, they have the user ID as well as the sign up date. So we are subtracting the sign up date with current date, and for that we're using the date def function, and we are aliasing it as days as gold user from golden user sign up. Now let's quickly run this query. There you go. So I think this data is a little bit older, maybe around 2014 or 2015. So it's been like years. So it calculated the number of days. So these are the ones. So maybe 2014 or 2013 as well. So the 2014, 2013. So those many number of days they've been a golden customer. So they are kind of really loyal customers for this particular restaurant. Now, what is the most popular product among all golden users? Now this particular question is again a little bit drilled down. So we have found 3 top selling products, right? So now he wants to filter out the golden users only. He wants to know each and every golden user, what is the product they have ordered amongst all the orders from golden users alone, which is the highest selling product. So he wants to take care, or I mean to say, take special care of the golden members. So let's try to investigate that. So there you go. We wanted the product name as the first column. Second, the product ID. And we also want the product name. So the product name is present in product details and user. The golden users, the details of golden users is present in golden users table. And we also want the product name, which is only available in the product data table. So to map it, you need to prepare a join in between 3 different tables. And after that, you need to group by product name and order by purchase count, right? So, and we also need only one row of it. So we're limiting to the one resultant row. Let's run this and there you go. So in premium customers, Shahi Paneer is most ordered and the purchase count is 7. Now proceeding ahead, which is the 8th question for today. What is the total sales revenue generated in each year? So he wants to know year-on-year growth of this particular industry or restaurant. Let's run or write a query for that and run it later. So for this, we're using the datetime function again. Now we have a column which is created date, like the customer creation date. So we are taking it and we are splitting it in terms of years using the datetime function, and we are aliasing it as year, right? And apart from that, here we have sum of prices, total sales revenue from sales, join product and product ID, and group by year using the created date, right? Now let's run this command. There you go. So in the year 2017, we have 1940, 2019, and so on. You can also try to sort these numbers in a descending order, which is, I think, already kind of done. No, it's not done. So you can also order this by the year, or so this can be done using this particular column here. You can order by year. So let's take that as a homework for you. And so far, so good. So this way, you can identify what is the sales growth or revenue generated on yearly basis. Now, we will be proceeding with the 9th question, which was the same which we discussed before. We just wanted to order it in terms of years, right? So just kind of, you got the homework right here itself, order by year. And maybe you can also provide the SC in the descending order. Now, let's run this command. There you go. So in the descending order, 2020, I think the data is about 4 to 5 years old. So here we have it, 2020, 2019, 18, and so on. Now, the next question. So the next question is the 10th question. What is the average gold sign up compared to just sign up for users? The thing is, what you need to do is, you need to check the intervals. The interval between the current date as well as the last sign up dates, or the, what's the interval between, let's say today one user signed up just for normal sign up, and after 10 days another sign up comes in. So basically he wants to know the frequency of, average frequency of sign up and compare it to average signups of gold signups. So here we will be using average aggregate function alongside with the date def function, which is a date time function. So here you are just giving the difference between sign up dates and gold sign up dates. So the users, you'll be joining the table with the users, and you will be finding out the average date difference between the gold signups and the normal signups. Run this query and see the output. So before we run, so you can see there are multiple select statements here. So it's like a subquery. So what we are doing is we are trying to select already filtered columns in this particular part, and we are aliasing this as average gold sign up time. So whatever the extracted part of this query is aliased as average gold sign up time, and inside that you also see another subquery which selects the date difference between the regular sign up time, and it is all combined and encapsulated inside the external select statement. So this is a brief introduction to subqueries in SQL. So now let's execute this. So there you go. For the average gold sign up, the average days is 1021, and the average normal signups is like 3071. Because we are comparing this to the current year, current date, and the data is about 4 to 5 years old, we can see a huge gap or interval between the signups. But say we are in the same 2020, or say the restaurant is still running current date, then it might be a little, the frequency could have been reduced a little. The number here, the frequency seems to be a large number, and you might almost think there are no signups happening these days, but it's not like that. If ever we had the latest data, let's say we add the new data into the database, then we will have new updates here as well. So I think we got this sample data from the client. So he just wants the sample codes, and whenever he updates the data, I think he will have a complete overview of what he's looking at. Now, the next question, which is question number 11. So, how many gold member users have ordered how many number of times? So, let's imagine today someone from the users group decided to upgrade to gold member, and now the client wants to know how many number of orders that person has placed from today, or let's say a week before somebody got upgraded to gold member. Since that day to the current date, how many number of orders did that person have ordered? So in the previous questions, we found it like we have about 5 gold members in the restaurant. So he wants to know how many number of orders did gold members pay. Now let's write the query for that. I think we might have to club sales data, and we might have to club with gold users data and the product data as well. Now, maybe product we will see down the line. I think sales and the gold users should do. Let's try to write the query. So the query seems a little easier. You just need to make sure you consider the user ID column and count the number of product, or product ID, the number of products he ordered as order counted from sales. So we have a product ID column in sales, and you can just, or in place of product ID, you can just place a star. You basically have to count the number of rows which are belonging by the gold users, and then group by the golden user ID, right? So let's run this and see the output. There you go. And in case you wanted to find out the best or the highest orders candidate, then you can give it by this particular one, or you can just copy the alias and paste it here, and descending DES. Find out order user ID 1, the guy from the premium, got so many orders. This is the highest number, right? So let's check here. There you go. Now let's move ahead with the 12th question. What is the total amount each customer spend on online food delivery? So now I think we have about 10 users, 10 customers, and now the client wants to know what is the total amount they spent on his restaurant from day one. So this is quite simple. Let's try to answer this query. So basically we have user ID and some sales data in sales table. But to get the exact price of each product, we might have to link up with the product table as well. So we want to know how much amount they spent, right? They, in the sense, the customers. So we want to know customer number 1 paid how many number of dollars, customer 2 spent how many number of dollars. So we also have added the user ID column here, and the next column would be the total price they paid till date. So we will be using a sum aggregate function on price, which we will be getting from the product table. So we have placed a join there, and we will also group by user ID, and I think we can also order by, so that we can find out the most loyal customer, and we will write it down as order by. And now let's run the query. There you go. So the person, okay, let me do this DESC and run this again. So the person user ID 1 has paid the highest total amount. So he paid highest bills, $1,350. There you go. Now proceeding ahead, we have the 13th question. What is the frequency of customers visits to online platform? So it is a little similar to this particular one that we preferred or solved here using time date functions in the question number 10. Now it could be a little similar here. Let's try to solve this question. To find out the frequency of customers to online platform. And he did not mention if we are focusing on normal users or if we are focusing on golden card users, right? So we will be dealing with the sales table as well as the customers table. So you can see we have two different customers table. One is users and another is golden users. So far, after executing so many queries, we found out that the group of people who are in normal users are the ones who prefer to upgrade to golden users, right? So I think if we just match up with users table, we will be good enough. So we will join along users table as well as sales table, and we will find out what's the frequency of online orders using the time date functions. Let's proceed with that. So there we have it. We will select the user ID column and we will count the order created date, and it will be renamed as visit frequency from sales data table. So I think we don't have to go through the customer specific data. I think we will be happy with the sales data alone. So now let's group it by user ID and run the query to see the output. So on a regular basis, the frequency of customer ID 1 is 7 and remaining all is so along. 3 is 6, 2 is 3, 4 is 2, 5 is 2, and so on. Now let's proceed with the next question. What is the first order purchased by each customer? Again, it is kind of a date and time function related. So when they got registered, the day they got registered and after the registration, what was the first product they ordered from the restaurant? So this is what we have to find out here. Now let's proceed with answering the query. So here we go. So we will be selecting the user ID column. Along with that, we will be selecting the created date, the date when the registration or the customer was created, signed up. So that is the column we are selecting. And we will be using an aggregate function where the date is minimum. And that day will be the first order date from the product name. And from sales, yes, right? So we will be joining the product table to identify the product name. If you check the sales data, you just have the product ID there, not the product name. For that reason, we will also join with product data so that we can match the product ID from sales table with the product ID from product table. And where they match, we will check the created date should be equals to the minimum of the date when they got registered from sales data table, and user ID is equals to sales user ID grouped by sales user ID plus product name. Now let's run this query. Control enter, and there you go. So the first order date for user 1 was 2016 May 20th, and he ordered Shahi Paneer and so on for all the individual customers. Right, now let's proceed with the 15th question. What is the most purchased item on the menu and how many times was it purchased by all customers? So it might be a little ambiguous. So you might have vegetarian customers as well as non-vegetarian customers. So let's say there is a high frequency of non-veg item, then a certain customer might not have bought it. The vegetarian customer might not have bought it. So there are multiple ambiguous situations here, but still we'll try to answer that. So we will be basically counting the total count of orders made, product name, and sorted by total number of orders they placed. Now let's try to execute this query, and there you go. So we have identified the most sold item and how many times that each customer have bought it. So here we have limited it by 1. If you eliminate it, then let's say we will get all the details. So all the details of all the items which were ordered by every customer. So I think Shahi Paneer was also ordered by some non-vegetarian customers, and this is equally the highest number of or highly found out uh, recipe in this particular restaurant. So this was highly sold to all the customers. They preferred this one. Now, proceeding ahead, which item is the most popular for each customer? So everybody has their own special choices. So somebody might have ordered maximum number of Shahi Paneer, somebody might have ordered maximum number of Gulab Jamuns, alright? So we will find out on an individual customer basis that which was their favorite or most popular dish or recipe. Now let's proceed with writing a query for this one. So basically, we will select the product name first. We'll select the product name column, and we will count the total number of purchases of each and every item on the product menu. And then we will map it to each and every user, right? We will find out the count of all the products ordered by every person and then select the maximum orders. Let's say user 1 comes to the restaurant, he orders gulab jamun for 10 times, shahi paneer for 20 times, and some other recipe for about 15 times. Now, out of all these, gulab jamun, which was ordered 20 times, will be selected. So that's our approach, which is here spaced inside a subquery, and this is named as a subquery. And then we will find out with the condition where subquery.userid is equals to sales.userid. Now let's execute this, and there you go. So user 1 had his favorite, which is our Shahi Paneer, and Dal Makhani for user 3, user 2, which is butter chicken. Now, instead of user IDs, you can also make some modifications to this particular query and identify username as well, right? Now, let's proceed with, maybe you can take it as a homework and let us know in the comments if you were successful to extract username as well. You can just add a user name column here, and along with the user ID, you'll get the username as well. Now, let's proceed with our next question, which is 17th question. Which item was purchased first by the customer after they became a member? Brilliant. So, there are more instances where you just visit a restaurant and then order food, eat, and come out. If and only if you preferred, like the taste, that's when you try to become a member, right? So before they actually became a member, just visited the restaurant and just ordered something. So they want to know which was that specific item. So the client here wants to know which is that specific item which made them to become a complete, lifetime member to that particular restaurant. So make sure that he wants to make sure that that particular item will stay on the menu for long durations so that he can attract more customers. That's the analogy behind this particular question. Now, let's try to answer that. So there you go. We will pull out the order ID, customer user ID, and product name, and we will make sure that the created date is minimum, which is the first order. This approach is similar to the previous one, and even we are calculating the gold user sign up as well and the product name, and we will just try to extract the result out of it. Now, let's try to run this. Shortcut key, which is Control Enter. There you go. So user ID 3, before they became a customer, ordered dal makhani on the specific date, whether they became a customer or, on the date he ordered this one, and it made him like the restaurant, and then he became a member, right? So this was the information which the client wanted to know. Proceeding ahead, we have which item was purchased before the customer became a member. I think which is a little relevant to the previous question. Maybe it is a repeated question. Or let's identify which item was purchased before the customer became a member. Yeah, this is similar to the previous one. Now, proceeding ahead, we can just eliminate this question as repeated. And proceeding ahead, we have the 19th question, which is about what is the total orders and amount spent for each member before they became a member. Okay, this is a little similar to the previous question, but here they want to know what is the total number of orders they placed as well as the total amount they spent before they became the customer. So we will have to use the same time and date functions and use the aggregate function minimum where the membership was created along with adding up 2 more columns. So those 2 more columns will be the total orders, count of orders, and sum of price. Now let's proceed with answering this question. So we just copy pasted the same query. All we did is adding 2 more columns, which is counting the total orders and summing up the price they paid. Now let's run this query, Control Enter, and there you go. So you can also order it by the total amount spent, which is I think we already did. So here you have the user ID, total number of orders placed, and the amount. So user ID 1, seriously like the restaurant here. Now proceeding ahead with the last question for today's session, rank all the transactions for each customer whenever they are an XYZ gold member for every non-gold member transaction mark as any. I think it should be NA. Okay. So he wants to rank all the transactions only of the gold members, and every time a non-gold member is involved in the table, in that particular row, we need to just add it as no, not applicable, something like that. So NA. So let's try and solve this. I think it might take a little effort to identify the solution for this. Let's try it out anyways. So this calls for a conditional statement, right? Maybe like in programming terms, like a switch statement. So whenever we find out an ID, user ID, which is not from golden sign up table, then in that place you can just mention it as the transaction call. You can just mention it as NA if user ID matches or if user ID is equals to or matches with the golden user sign up table, please yes or the transaction details. If not, just type down the text in single quotes as NA. Let's try it out. There you go. Now let's run this query, and there you go. So for customer 1 and a couple of others, we have just termed it as NA. And after he became a gold member, I think we have a transaction here. So yeah, there is a possibility that the customer would have been a normal customer before and he turned out into a gold user. And if ever he had ordered something, then we have his order transactions here. Transaction rank. So in terms of transaction ranks, as the ones we got results before, user 1, he was a normal customer before, but he turned out to be a golden customer, and he was the one with the highest rank and highest number of orders. So there you go, right? And if you wanted to extract this table, you can just copy row, or you can download the data table. You can export this particular data table and then add a filter to it and filter out all the NA values, and you'll get the golden customers and their ranks. And so far so good. We have answered all the possible questions that we received, and we will be also saving this workbook as a Google document, and it will be accessible for all the learners. And if you want in-depth learning experiences on all the SQL fundamentals like CTEs, join statements, how to load data from different data sources onto a SQL workbench, and case, etc., then we will have those tutorials attached as well. And we have a complete playlist on SQL tutorials. And apart from that, this calls for an end of this session.
Imagine you're building a system like an app or a website. How do you figure out what the users need and how they will use it? This is where use case diagrams come in hand. They act like a simple drawing that shows how different people or system interact with your app to get things done. For example, if you're designing an online shopping app, a use case diagram can show you how a customer can browse products, add them in the cart, and make a payment. It's just like creating a story of how users interact with your system step by step. In simple terms, a use case diagram is a way to visually represent who will use your system we call them actors, and what they will do, these are known as use cases. It gives you a clear picture of what your system should do and helps you plan how everything will work together. These diagrams are super helpful because they show the big picture without going into confusing technical details. They also help teams, including non-technical people, understand the system, and they also ensure that you're building something that meets the user needs. So in this video, we'll cover everything you need to know to get started with use case diagrams. And even if you are completely new to the topic, in this video, we will explore what use case diagram is, use case diagram notations, relationships, how to draw a use case diagram in UML, common use case diagram tools and platforms, and the mistakes which we make often in use case diagrams. We'll also see some of the best practices, and by the end, you'll not only understand use case diagrams but also feel confident in creating one for your own projects too. So let's get started. So what exactly is a use case diagram in UML? A use case diagram in Unified Modeling Language is a visual tool that helps you understand how users, also known as actors, interact with system to achieve specific goals. Think of it like a straightforward diagram that shows who is using the system and what actions they are performing. For example, in an online shopping system, actors are like customers and administrators that can perform tasks such as browsing products, adding items to the cart, and managing inventory. A use case diagram highlights these interactions, providing a clear view of a system functionality. By simplifying the system functionality, use case diagrams play a crucial role in planning and designing systems that truly align with your user needs. So now let's start by understanding some use case diagram notations. So for this, we have started using our Lucid chart website, and here you just have to select on the use case diagram template and you will be just redirected to this interface. And it's very easy to use and one of my favorites. So I use this particular website to create UML diagrams. Alright, so here when you just enter to this page, so you can see a lot of shapes over here. These are only the annotations we are going to talk about. So these notations are basically simple visual language that developers, designers, or even non-technical stakeholders can use to understand and discuss how a system works. We'll break it down step by step. So first, as you can see over here, we have an actor. Actor, you can just select from this particular shape option and you can just drag and drop. So what does actor actually do? Here, this is the actor over here. So actors are the external entities that interact with your system. This could be users, other system, or even hardware devices. Basically, in simple terms, they are the people or things using your system. For example, in an online shopping system, the customer and the admin are the actors. There would be two particular actors. One would be primary and second one is secondary actor. So let's say customer is the primary actor and admin would be the secondary actor. So they initiate action or use cases. We'll be talking about it later. And identifying actors properly is very important because it ensures that your diagram accurately represents how the system behaves. Next, we're going to talk about are the use cases. So for use case, we use this particular shape over here. So you can just simply drag and drop from here. All right. So I'll just show you. So use cases are like the scenes in the system story. They represent specific tasks or actions your system can perform. Let's say, for example, in an online banking example, use case might be place order, track delivery, or even update information. These are the key functions your system provides in a diagram. Use cases are represented by ovals. As you can see, this is an oval over here. So use cases are represented as ovals, keeping things simple and easy to understand. Next, we're going to talk about is system boundary or system. So for the system annotation, we are just using this rectangular shape. System boundary is just like a box that separates what's inside the system and what's outside. It defines the scope of the system, what your system will handle, and what is external. Let's say, for example, in an online banking system, actions like browsing products or managing inventory are inside the boundary, while external actors like payment gateways are outside. The system boundary helps clarify these limits, ensuring everyone knows exactly what the system is responsible for. So in the diagram, the system boundary is shown as a rectangular box surrounding all the use cases. So why does these annotations actually matter? So using these annotation ensures that your use case diagrams are actually clear. So whether you're explaining the system to your team or presenting it to the stakeholders, these simple symbols act as ovals for use case and the system boundary make complex system easier to communicate. So now let's move on to see how these notations come together in a full diagram. So before we move on to diagram, let's take a moment to understand the relationship used in use case diagram. So now let's understand the relationships. Why relationship is important? Because they show how actors and use cases interact and connect, giving us a complete view of the system functionality. At first, we have association relationship. So this is an association relationship over here, and this is the most basic type of relationship. It shows the interaction or communication between an actor and a use case. You can see an actor is a customer over here in an online banking system. The customer would be the actor which interacts with the transfer funds over here. And the line between the two represents the relationship. This is the relationship, this arrow. Now the second relationship we are going to talk about is the include relationship. So include relationship means that one use case relies on another to complete the functionality. It shows with the dashed arrow pointing from the including use case to the included use case. So the including use case over here is the compose post and the included use case is add image. In social media, the compose post use case might include the functionality of add image. So this means whenever you're composing a post, the option to add an image is automatically part of this process. Let's talk about the third type of relationship, which is the extend relationship. The extend relationship is all about optional or additional functionality that occurs under specific conditions. It's represented by a dashed arrow within the keyword extend. So we're using this keyword extend. For example, let's say the flight booking system. The book flight use case might be extended by select seat. So these are the extension points over here, and select seat might be the extended one. So if the user chooses to pick a specific seat, this step isn't mandatory, but it adds extra functionality whenever needed. So as you can see, this select seat might add some extra functionality, and that is why we are pointing an arrow towards this. Now let's talk about the fourth type of relationship, which is the generalization relationship. This relationship is also known as is a connection between the use cases. These are the use cases over here, and so where one use case is a specialized version of the another one. So it's represented by an arrow pointing from the specialized use case to the general use case. For example, let's suppose in a vehicle rental system, the rent car and the rent bike are the two specialized use cases of the more general rent vehicle use case. So this shows that renting a car or a bike shares some common functionality with renting any vehicle. That is why we have pointed towards this generalized use case, and here the generalized use case is the rent vehicle. So why does these relationship matter? When we draw a use case diagram, you'll just know about it more. So these relationships help us to see how different parts of a system work together and make the diagram more meaningful. Before we get too far into this tutorial, let's talk about how we are going to make a use case diagram. You could also use a pen, paper to draw them out, but a diagramming application is going to be way more easier. And today we are using this Lucid chart, and you can also use it because it's free to use. You just have to click the link to access Lucid chart website, enter your email, and then you can just follow along. So now we're just making our system a banking app system over here. So we have just used this rectangle and we call our system. This is the system over here, and we just name our system as banking app. You can also increase the size if you want to. Okay, this is a banking app system over here. And anything within this rectangle happens inside the banking app, and anything outside this rectangle doesn't happen in the banking app. The next element we are going to choose is are the actors. So we'll just select an actor over here. Okay, so we'll just place the actor over here, anywhere over here. So an actor is going to be someone or something that uses our system to achieve a goal. That could be a person, as we have already discussed. So for this banking app system, just guess what would be the most obvious actor. Obviously a customer. So we just name our actor over here as customer, okay? Now let's talk about the another actor we want in our diagram. In the bank, that would be obviously the bank. So we'll just place, let's say, a bank over here. Alright, so in this case, the customer are our primary actor and the bank would be the secondary actor. So we'll just place our secondary actor right over here. Alright, so couple of things are important to keep in mind. First, it's important to note that these actors are external objects. They always need to be placed outside the system. Second, actors need to be thought as types or categories. For our banking app, the actor isn't going to be a specific individual. We wouldn't label our actor as John, Chase, or some bank name. We can keep it categorical, and this brings us to the topic of primary and secondary actors, which I already told you before. So the primary actor here is the customer. The customer is going to initiate the user system. They're going to pull out their phone from here and open up the banking app and do something with it. Bank, on the other hand, is the secondary actor. So bank is only going to act once the customer does something. If the customer goes on the app to see how much money is in their bank account, only then does the bank engage with our system to provide the balance. So primary actor should be on the left of the system over here, as we have already mentioned, and the secondary actor should be on the right and the primary actor should be on the left. So now the next element we are going to talk about are the use case. So this is where you really start defining your system use case. So we'll be using this oval use case over here. So it is represented as an action that accomplishes some part or some sort of task within the system. So they are going to be placed within the rectangle because they are actions that occur within the banking app. So the first use case we will have is called the logged in. Okay, we'll have a use case as logged in. We'll also have another use case known as, let's suppose, check balance. Another called transfer funds also we can use for making our final payments. So let's suppose this is final payments. So we will have this in the logical order. At first, the customer will log in. They might check balance. And before this, we will have one more use case as transfer funds. So we'll just keep it before making payments option over here. Alright. So these are the use cases we have listed in a banking app. Login, check balance, transfer funds, and make payments. So you can see that each of these use cases start with a verb and reinforces an action that takes place. We also want them to be sufficiently descriptive. If this use case only said transfer, that would be way too vague. Finally, it's good practice to put your own use case in a logical order when possible. So that is why we have put login at first, and that's where the first thing happens that will a customer use. The final element to use would be relationship. So now an actor by definition is going to use our system to achieve some particular goal over here. So they have to interact with at least one of the use cases within our system. In our example, a customer is going to log into our banking app. So we draw a solid line between the actor and the use case to show this relationship. So we'll just draw a line from here and just connect it. So customer will also use this check balance option. So the solid line which we drew, this type of relationship is called as association, and it signifies a basic communication or interaction, and the customer is going to interact with the rest of this using the same case as well. So now that we have drawn the solids line to each one of those, the banking app system, it will react. First, it will log in, check balance, transfer funds, and then make payments. So now we'll just talk about what our secondary actor will do. So now in which case the bank would interact with? Well, a customer wants to check their balance on the app. The bank is going to provide the correct amount. Let's draw a line between the bank and the check balance because the bank won't log in. So we'll draw a connection between a bank and check balance. Okay. Yeah. So when a customer wants to transfer funds or make payment, the bank is going to follow through with those transactions. We don't need to draw a line to log in because that process happens within the banking app. There's no need to go to the bank to actually get involved with the login process. There are three other types of relationship in addition to association. They are include, extend, and generalization, which I've already discussed. So when a customer types in their login information, a banking app is going to verify the password before completing the login process. But if the password is incorrect, the banking app is going to display an error message. So let's create two more new use cases to verify password and display the login error. But before that, let's just draw a line to make a connection between check balance, transfer funds. So now we will have one more use case as verify sufficient funds. Finally, when a customer would want to make a payment, our banking app is going to give them the option of paying from either bank or checking account, from the savings account. So we'll have to create two more use cases. Before this, we'll just put it over here. So before making a payment, you have this use case of verify sufficient funds. So we'll create two more use cases as pay from savings and pay from checkings over here, and we'll just place it over here inside this box. So now let's circle back to the verify password and use case, and let's talk about the relationships again. So how to verify password, it relates to the rest of the diagram. Neither of our actors are directly initiating this action. It's just immediately going to happen within our banking app every time there's an attempt to log in. So this is known as the include relationship. So basically, include relationship will show dependency between the base case user and an included use case. So every time the base case is executed, the included use case is executed as well. So when you have include relationship, you draw down a line with an arrow that points toward the included use case, which I have already told you before. So here the include relationship, which I have already mentioned, would be the login. Login as the base case and the verify password would be the included use case. So every time a customer logs in, our banking app will automatically verify password. This login use case won't be complete. So we draw a dash line with the arrow pointing towards the included use case, and we write included in double this thing, include over here. Next type of relationship over here would be the extend relationship. So when the base case is executed, the extend will happen sometime, but not every time. So when you have an extend relationship, you draw a dashed line with an arrow that points towards the base use case. So in our example, login is the base use case over here, and the display login error over here, which we have written as use case, is our extended use case. So our banking app won't display a login error message every time a customer logs in. This will only happen once in a while when a customer accidentally enters an incorrect password. Since this is an extend relationship, we draw a dashed line with an arrow that points to the base use case and write extend double between double chevrons. So with this, we have completed our UML diagram over here. As you can see, we have used all the relationship also, and we have described how we can connect, have annotations, and then just make a simple UML diagram. So let's also discuss the common use case diagram tools and platforms. So for this, we are using Lucidcharge because it's a collaborative platform, real-time collaboration and commenting templates for various diagram types. We also have different websites also. Suppose we have draw.io. So you can also use this website to draw your UML diagrams. So as you can see here, we are using draw.io. It's also free open source diagramming tool. It works offline and can be integrated with Google Drive as well. The next tool, we also have Microsoft Visio. So we'll just search on Google, Microsoft Visio. So as you can see, it's by Microsoft Flowchart Maker. You can also just simply sign in, and because it's a part of Microsoft Office, it supports various diagram types, including use case diagram. Then next on the list is Smart Draw. Let's search Smart Draw. So Smart Draw first on the list, it's user-friendly diagramming tool. You can just click on start now and just check the templates. We have different types of diagram, including use case diagram. Next on the list is our Plant UML. Plant UML. We can also use this. It's a versatile tool. It's used for creating UML diagrams. So now at last, let's talk about some common mistakes while making a use case diagram. So you should avoid common mistake that ensures the accuracy and effectiveness of the use case diagram. Do not add too much of detail that confuse people. Unclear connections lead to misunderstanding about system interaction. If you use different names for same elements, it would create a confusion. So use kind of same names. Incorrectly using generalization can misinterpret relationship. Also, treating the diagram as static can make it outdated and inaccurate. So keep these things in mind. Crafting a clear and effective use case diagram is very important for conveying system functionality and interaction, and here are some of the best practices. Use case diagram focus on capturing the core functions of the system, avoiding extraneous details. They ensure uniformity and help in organizing use case into coherent groups. So in conclusion, we can see a use case diagram serves as a powerful tool for capturing and visualizing the functional requirements and interactions within the system.
So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and their relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students, and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute. that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2 and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2 and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp and others. Then we have string data type, which includes char, this varchar and text. Finally, we have binary data types, and binary data types have binary, var binary and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division and modulus. Then we have some logical operators like all, and, any, or, between, exists and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to or less than equal to, not less than or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL Server, MySQL Shell and the MySQL Workbench. Expand MySQL Servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL Shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click Next. Now we'll configure our SQL Server instance. Here we will go with the default settings and click Next. And under Authentication, select Use Strong Password Encryption for authentication, which is recommended, and click on Next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on Next. And here also we'll keep the default settings and click on Next. Now, to apply configuration, we will execute the process. Once all the configuration steps are complete, click Finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on Finish. Now the shell and workbench has started. Now we'll connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL AT and enter the password to connect to the local host. The MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns underscore prive, component, DB, and much more.
Now let me now go ahead and open my MySQL workbench. So in the search bar, I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL workbench. And below under connections, you can see I have already created a connection which says local instance. Then you have the root, the local host, and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL workbench looks like. Here we learn some of the basic SQL commands. So first, let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country, and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district, and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe, and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL Intro. So the command is create database, and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL Intro. If I scroll down, there you go, you can see the name here, SQL Intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL Intro database. So I'll use the command create table, and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name. followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type, and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values I have passed in all the records. So first we have Jimmy, which is the name of the employee, then we have 35, which basically represents the age, then M means the gender or the sex, then we have the date of join, next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the date of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum. And since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here, this says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender, which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause, I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary, as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender, and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details, and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order, and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator, and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first, I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I've given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu underscore name, and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display these student names so that we can compare their length. Alright, I'll run this again, and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6. Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as let's say name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse, and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or ltrim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is ltrim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the ltrim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being, it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being, it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5, because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place, or at the 13th position, we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn 2 important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to. And then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function that is avg, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems. Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee underscore name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees, and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad, and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami, and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned, and here are the department names. So we have sales, marketing, product, tech, IT, finance, and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places. So I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright, now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma, now I want the total salary, so I'll use the sum function, and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 121 and 123, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S, So here S stands for the sales table. I'm going to use inner join C underscore product table as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121 we made a profit of $1,100, and for product ID 123 we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So This will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session, we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on my SQL workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay, now to understand inner join, consider that there is a college And in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket underscore ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay, now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join my next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c.name is equal to f.name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright. So let me use my select statement to show what are the columns present in the products table. Okay. So this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright. Now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description. So I'll write this column name. Okay. Then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join 3 tables, that is orders, order details and products. So first let me show you what are the columns we have in these 3 tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product. We have the price of each product. Then we have the order line number. Okay. So using the product orders and order details, let's perform an inner join. So I'll write select O dot order number, comma, O dot status, comma, I need the product name which I'll take from the products table. So I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma, since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are two address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, So based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes, I'll give my comma and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot, I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright, so that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL Joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called Classic Models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video, we will learn what is a subquery and look at the different types of subqueries. Then we'll learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database and we'll create a few tables as well. Okay, now if I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the AVG function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all, let's create a table, that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again, product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800. and the product type is it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300 and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400 and it's a non-luxury product. I'll give a semicolon and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30, and finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item and the selling price or the sell price from my table, that is products, where I'll write product ID in. I'll write my inner query select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were 2 products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees_b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees_b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees_b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees_b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than equal to 32, or let's say the age is less than equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use 2 tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than equal to 32.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column.
Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contain multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data, the order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies: order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement: in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a superkey, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables: the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables: the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency, by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write ampersand ampersand. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database, which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city, and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp_sort by salary. The other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp_sort by salary. And inside this I'll give my parameter, which was actually VAR, and this VAR we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in two parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total_employees, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter 2/. I'll write create procedure followed by the procedure name. It is going to be sp_count employees, and inside this I am going to give my out parameter and the variable name, that is total_employees, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total_employees. From my table, that is emp_details, where sex is equal to F, which means female. I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp_count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp_details. So I've used my out parameter and I'm creating a new variable called total_employees. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total_employees. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp_count employees. Now to call it, I'll write call the name of the procedure, that is sp_count employees. Within brackets I'll pass in the parameter as @f_emp. I'll give a semicolon. Then I'll write select @f_emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. There are mainly three types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we'll learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And Let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. You give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. you can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num. I'll give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20 I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see for Herath, the second record it says 2, which means there are two records for Herath. And if I scroll down, there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function. I'll write rank over, then I'll order by my variable that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter Notebook and the MySQL Workbench. You can see it here. So we will write our SQL queries in the Jupyter Notebook with Python-like syntax. If you don't have MySQL or Jupyter Notebook installed, so please go ahead and install them first. While installing the MySQL Workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL Workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from mysql.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in three parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql.connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in three parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright. Now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as ERR, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give ERR, and then I'll close the double quotes. After this, I'm going to return my connection. Alright. Let me give a comment here. We are going to assign our password, so we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write PW, and I'll give my password, which is simply @12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write DB equal to, this is the database I want to create, which is going to be MySQL underscore Python. Let me just scroll this down. Okay. Now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give PW, which is my password, that is exactly simply @12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL underscore Python. So I'll give a comment, create MySQL underscore Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as ERR, give a colon, and then I'll use a print statement. I'll write print. I'll use the formatting again, error colon, and I'll write within single quotes, I'll give curly braces ERR, and then I'll close the double quotes. Next, let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be mysql underscore python. Okay, after this I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it, and I'm going to paste it here. Alright, so what I'm doing here is I am creating a new function, that is to create a new database with the name mysql underscore python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and except blocks. So this try block statements will try to create my new database, which is mysql underscore python. In case it fails to create the new database, the except block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called mysql underscore python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line I'm going to create my variable which is connection, and then I'll assign it to a value none, After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write MySQL dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username. So user equal to user underscore name. Give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as ERR, give a colon, and then I'll use the print statement. F within double quotes I'll write error colon, within single quotes curly braces I'll write ERR, and will close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright, now to execute our SQL queries, I'll use another user defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next we'll use the try and except block. So I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except if the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write ERR and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, Now it's time for us to create our first table inside the MySQL_Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. I'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is MySQL_Python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here my SQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL_Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values. And now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 6293730, let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. You have Steve, George, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I've used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here my SQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in one parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as ERR, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting F error, give a colon followed by a space, within single quotes, inside curly braces I'll give ERR and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is I'll assign my query to a variable, let's say Q1. I'll give triple quotes. Within triple quotes I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is Q1 for the query. Next, to display I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable Q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of Q1 we'll put Q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have the respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that I am going to use the year function. I'll edit this query. Instead of Q1 I'll make it Q3, and here I'm going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to Q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here in Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our fifth query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next, now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list. and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I'm creating a empty list first, and then I'm creating a for loop, and I'm appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I'm converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column. It starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say $45. I want to update this particular record. So I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50 now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next, I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause where, let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL underscore Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read underscore query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was ER. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command. PostgreSQL is a very popular and widely used database in the industries. In this tutorial, we will learn PostgreSQL or PostgreSQL in detail with an extensive demo session. So in today's video, we will learn what PostgreSQL is and look at the history of PostgreSQL. We will learn the features of PostgreSQL and jump into performing PostgreSQL commands on the SQL cell and pgadmin. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux, and Mac OS. It is highly secure, robust, and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java, and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string, and boolean. It supports structured data types such as date and time, array, and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update, and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we will see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries, and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with two brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database which was SQL demo. So let me show you how to work on this PG admin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom and it says PostgreSQL 13.2 compiled by Visual C++. It has the 64-bit system. Okay, now let me tell you how to perform a few basic operations using PostgreSQL commands. So here let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards. So there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie, so I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings, so I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the PG admin. So here under tables I'll right click and I have the option to create a table, so I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want you can give these constraints such as not null, so that student roll number column will not have any null values, and I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. you can write drop table students and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell and here if you write \d and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constraint or primary key or foreign key and others. Let me go back to my pgadmin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. I'll go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, Okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men. We have successfully updated the genre as drama, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. So you can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into 2 lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies, where let's say the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright, like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL, like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL underscore demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values, so I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay, next I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay, next we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay, now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table, and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright. Now, as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here, for all these employee names, there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID. And if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table. So I'll write select star from employees order by. I want to order the employees based on their salary. So I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names. So it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany, or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of AND I'm going to use OR. Their department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information, and these are the top 5 employees that have the highest salary. Okay, so this is one method of, or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here, and here after descending I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go, it has given us the first 3 rows, and you can see the top 3 employees that have the highest salary, since we ordered it in descending order of salary. Alright, you can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright, we have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials, so you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is, I'll copy this, and instead of %, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D, or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum, and inside the sum function I'll give my column name that is salary from my table name that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay. So now let's update our department column. So what we are going to do is wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by. Since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function since I want to find the maximum salary for male and female employees. I'll give an alias name as maximum underscore salary from my table that is employees, group by, I'll write gender. Okay, so let's run this. There you go, you can see. So one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select, since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp underscore id from my table name that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say, salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement, but before that let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes I'll write low salary. So this is exactly like an if-else condition. Next I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this, we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have three conditions here: for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have ordered our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We'll compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright, now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the / an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a /. So this is also a comment in PostgreSQL. Alright, so first of all we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, -100, it is going to return me +100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was -100, the absolute of -100 is +100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers. Let's say 4, 90, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case, 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now, like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2 because 2 is the least number that is present in this selection. Alright, now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder. 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power. Let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say power of 5, 3, it should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I'm going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright, now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string. Now let's say I want to combine PostgreSQL I'll give a space, comma, I want to merge PostgreSQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay, now there are functions like left, right and mid in PostgreSQL. So what the left function does is, it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is, it will count 5 characters from left, so 1, 2, 3, 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay, now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is, it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here, India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function. Then I'll give my function name as count emails. And as you know, functions have brackets. Then I'll write returns, the return type, as integer. Then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select. I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon, and then we'll write return total emails. As you know, user defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language PostgreSQL. So the way to mention is PL PG SQL. Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement, where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and OR operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions. And finally, we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL.
In this session, we will learn about how to join 3 or more tables in SQL. That's right. So far we have a fundamental understanding of how to join 2 tables. But in a few situations, you might have to extract the data by joining 3 or more tables, right? So that's exactly what we are going to discuss today. Now, without further delay, let's get started. Now, we will jump into the MySQL workbench where we have our query ready. So here we will be using 3 tables: employee details, employee register, and employee joining register. So we want employee name, contact number, and joining date. Joining date is available in joining register, contact number is available in employee register, and employee name is available in employee details, right? So here we are utilizing all 3 tables and joining them to extract these 3 columns. So here I'm providing the table name and the column name to make sure that the SQL workbench will not get confused which employee name, which employee name column should I access, which table should I use. So to clear that confusion, I'm providing the table name. So MySQL will use employee details table, and from there it will extract the employee name column. And contact number, to be sure, it is present in only one table, so it will go to employee register. And joining date, it is also present in only one table, so no need to specify the table name. But to be on safer side, if you want to add, you can add, that's well and good, and it will create an impact to your interviewer considering that you know about the syntaxes. So I'll just follow the normal syntax the way I'm going now, and now I'm trying to join. It's the same operation what you use to join 2 different tables. So you'll just use the join clause and give the second table name and on what basis. So I'm joining these 2 tables on the primary key employee ID. So both tables have the same common employee ID. So based on that, I'm joining these 2 tables, and then you will use the join clause once again and give the third table name here, and based on which primary key or which common key. So this is the one which is common in both the tables and is unique, which is the employee ID. So I'm using the same one to join the 2 tables with the third one. You can follow the same syntax and join another table to it as well. So with this, let's execute this particular query to find our answer. So there you go, you got the query executed and you have the table over here with employee name, contact, and joining date. Let's quickly get back to MySQL workbench. So here, let's say you wanted to create a table and load the data. So if the data is minimalistic, maybe the data about 10 rows or 15 rows, you can manually create a table and insert the elements into your table using such insert commands. But this set, like mine, which is in the Excel spreadsheet and has about 10,000 rows, would you like to, write 10,000 insert commands? No, right? It would be really time consuming. So for situations like this, MySQL Workbench has enabled developers to load the data from spreadsheets within a few steps. But before we get started, let's check our column headers. So here you can see it is not compatible with the MySQL Workbench or SQL commands, right? So it has a space and it has a word row and it is a keyword in MySQL, right? So we don't want that confusion. So for that reason, we will try to modify this maybe using an underscore, right? Similarly, for the row ID, you can eliminate space and use an underscore. And when it comes to order ID, the same. So just let us quickly change all the column headers so that they are SQL compatible. There you go. So we have replaced all the row headers with underscores and made them SQL compatible. So let us save it. And when you're saving it, just make sure that your Excel file data is also having the SQL compatible name. So here we have load CSV to MySQL. So here we have the name with space, right? So let's try to change that to lowercase Excel data, and right now it is SQL compatible. Now quickly let's go back to MySQL Workbench. Here we have it. Now you can just create a new table. Just right click here, or you can also do it from here. Create a new database, and the new schema will be the name of your data set. So let's type it as Excel data or just Excel, and apply. Now this is the schema. Apply. Now you have Excel right here. Just drop down, and here you can see the tables. Right click the tables, and here you have the option of import data wizard, right? Just click on that. Now browse your folders and have it. So yeah, another notification for you guys. So you need to save your Excel spreadsheet in the form of comma separated file, right? Let's quickly go back and do that. Open your spreadsheet, go to file, save as comma separated file, save. There you go. Now let's get back to Workbench, and now I think you will be able to find it. Just open, next, drop table if exists. Make sure you do that to be on the safer side, and check all the names here. So we have a problem with row ID, but that is something which you can fix down the line. And before you go to the next step, check all the other names as well. Every other name on the column header is fine. Just the first one, we can just alter the table, not a big deal. And next, it should start importing. There you go. The data file got imported. Of course, it took a little while because it's 10,000 rows. That's normal. Now let's quickly go to the next step, and here you can see 9,987 records imported successfully. Just click on finish, and I think it should be shortly done. Let's close the schema, go to the query table, and yeah. So you can quickly refresh so that you will have the Excel data over here. Now let's use the database that is Excel. On it. Now we are in Excel database. Now the table we are looking for is select star from the data name. The data table name is Excel data without a space, semicolon. Just quickly run it, and I think we should be shortly able to see all the data sets right over here. Yeah, about the first column ID, we can simply use the alter table function or query to change the name. Let's quickly do that with the table name, alter table, rename. Okay, what was this? Can you copy that? Copy field name, rename row ID to. So a small syntax error there. So I think they should be sorted. Yeah. And now let's quickly run this, and I guess it should be done. Now let's quickly run the select command again. There you go. So we have the row ID, order date, shipment mode, customer ID, customer name, etc. And everything is as per the expectations. And that's how you can load Excel data to MySQL Workbench. We will learn about the top 5 interview questions in SQL that you must know to crack your business analytics interviews. Now, without further ado, let's get started. So, speaking about the top 5 interview questions, let's quickly jump to the workbench of SQL. So, I'm using MySQL Workbench, and here we have a database called Use Simplilearn. So SLP is the database name. So we will be using the use command to get access to that particular database. So we are in access to it. And now let's quickly check our tables. Show tables. There you go. We have a few tables here: book collection, book order, employee details, joining register, and employee register. So let's go with the employee details. So I'll just simply shoot a command, select star from emp details. So now we have our employee table. So we will be using this particular data set to run few queries from our interview questions. So getting back to the interview questions. So most commonly you will be asked the following interview questions. So the first question is, you will be asked to find out the names of the employees that start with the vowels. So A, E, I, O, U. So they will ask a question, give me the list of names that start with these 5 letters. It can be either A or E or I, O, U, right? So what's the question? So here you will be using like operators and not like operators. Let's say they want the names with vowels. So you can just use the like operator and use this particular command. Select employee name, that's the name of the column, from employee register or employee details, and then where employee name is like A modulus, which means it should start with A and it can have any number of alphabets after that, right? So let's quickly also check what do we have in employee register. So I think it's a similar table to employee details that we used before. We have the same details here, so not a problem. Now let's try to extract the names of the employees. Those names start with vowels, right? So we will be using the where clause and like operators. Run the command and there you go. So we have 3 names. So if you are able to answer this question, they might ask a similar question with a little modification. So this time they might ask you, give me the list of names that will not start with vowels. So you will just replace the like operator with not like. So either they'll ask the questions which might start with vowels, or they might ask a question which does not start with vowels. This is one of the common questions. Now going to the second question. So here also they will give it a simple start. They will ask to give the details of the employee who has the highest salary, or they will ask you to give the highest salary. You can simply use the max aggregation and you can get the maximum salary. So we have $87,000. And sometimes if you are able to answer this question, they will make it a little tricky to you and they will ask, give the second highest salary. Here you can use offset, or there are multiple possibilities, but let me give you the simplest one where you can have the same query. Only difference is where salary is less than max of salary. First, the subquery will be executed which will extract the maximum salary, and the next one is less than. So it will give you only one row which has a little salary which is less than the maximum one, right? So simply let's execute the query. So we will have the answer. So the next highest salary is $78,000. Now moving on to the third question. So sometimes they will ask you to use the update commands as well. So here we have some salary details of our employees in the employee register. What I'm going to do here is, let's say this is the appraisal period and they're giving you 15% hike to all the employees. So you need to update the salary column. So what you do is simply update table name salary plus salary into the percentage of hike, which is 15%. So here we are adding that particular percentage in the form of decimal numbers, which is 0.15, and simply run the command and you have it. Now you can just simply query the same detail, which is select star from employee details. So you will have the updated salary list here. There you go. Now let's proceed with the next question that we have in our list, which is about select the employee name and salary from a given range, right? If they ask you, give me only the range of employees whose salary lies between 50,000 to 70,000. So you can use the between operator here and range of numbers, that is 50,000 and 70,000. Just run this particular code and there you go. You have the details. So there are 2 employees whose salary lies between 50,000 and 70,000. Now the last question is, they might ask you to extract the details from a certain department. So basically This might also turn up to find a difference between having and group by clause. Sorry, having and where clause. Yeah. So this is one of the common interview questions where they will ask the difference between having and where clause. So when you are implementing group by in your query and you're also implementing some aggregate functions like count, sum, etc., minimum, maximum, in those situations when a group by clause is involved, then you can use having. When there is no group by function, then you can simply go with the where clause. So here I'm trying to extract the number of people present in finance department. So I'm not grouping by department, so I can just use where clause and run this. And now in situations where I have to group by, when I have to implement group by, in those scenarios, you can include having clause in place of where. So that is the fundamental difference between having and group by. And also you got the understanding of group by command here.
Imagine walking into a giant library. This isn't just any library, it's huge. There are rows and rows of shelves, each packed with thousands of books. But wait, you don't need to read every book here. You're just looking for specific ones like books about space or stories about superheroes. But finding what you need is such a huge library. That's going to be tricky. This massive library is like a database. A database is a huge collection of information stored neatly, ready to be used. It holds everything: name, address, grades, prices, whatever data you can think of. But sometimes all that information can be overwhelming. You don't want to shift through everything every time. You need something specific, right? That's where views comes in. In this video, we will explore views in SQL, explaining what they are and how they simplify working with databases. We'll also cover how to create views, manage them by updating, deleting, and listing them, and also introduce different types of views like simple, complex, read-only, and those with check option. We'll also dive into materialized views which store data for faster queries. And by the end, you will understand how views can manage data easier and more efficient. We will also look into a quiz question to clarify your understanding. So, what exactly is a view? Let's go back to our library example. Imagine if you had a magic window, a special one that only shows you the books about space or superheroes that you are interested in. You don't have to wander through the entire library anymore. You just look through your magic window and it gives you exactly what you need. That magic window is what a view is in the world of databases. A view is a special virtual window into a data that shows you only what you need to see. And the best part is, it's not actually storing any new data. It's giving you a filtered look into a huge database. Think of view as a shortcut, making your life a whole lot easier. So let us get into the demo part about how to creating a view and the types of views in SQL.
So let's start with the demo part, that is how do we create a table in MySQL. So here, as you can see, I've just logged into an online compiler, and now we will just learn how do we create a table, and then we'll move on to creating views and the types of views. So first, to create a table, just enter this command, just write over here, create table, and then just enter the table name. It could be something like student details, and here you can give the student ID name. We want a student ID name in the first row, so we'll just keep SID, and the type of the variable is integer, so we'll just mention int over here. And since it's a primary key, we'll just mention it over here, primary key. Next variable can be something like name, and for this the type is varchar. You can just enter any number here. Suppose I've entered 255. Comma. Next, mention the address. Again, it's varchar address. So as you can see, we have created this table with student ID name. So we have to give your underscore, student ID name with primary key integer type, and the name and the address over here. So after we have created this table, we want to insert data into the table. This is our next step. So to insert data, what could be the basic command which you can write? Can be something like insert into student, the table name, student details over here, and just mention what all columns which we have, attributes we have created, which is S underscore ID. Next is name, and then we have address over here, and then we mention the values. So now that we have created table, and then we can enter our details over here. So these are the values which I have inserted, which is Harsh, Ashish, Pratik, Dhanraj, Ram. Okay, so like this you can enter the values over here. And now if I want my records to be displayed here, the command which I'm using is select star from student details. So all these, the table will be shown here. So we'll just click on this run button over here. Okay, so now you can see this is the SID name, number, and the names which we have mentioned over here. So as you can see, this is the output generated. This is the SID, the name, and here is the address. So as you can see, the table is created now, and the output is also shown. Now we will move on to the main step, which is creating a view. So what exactly is a view? A view is like a window that lets you see specific data, as I've already told you in the intro part. So now let's say we only care about students with SID less than 5. Okay. And instead of running the same query every time, we want to create a view. So here's how you can do it. You can just simply enter a command. So here's how you can create a view. So just mention this command, which is create view detail view as select name, comma, address from student details. So student details is the table here which we have already created before. And I want the student ID less than 5. Okay. So I want this to be shown here. So we'll just simply click on run over here. So as you can see, this is the error it's showing. Why is it showing? Because line number 20, create view must be the first statement in a query batch. So to resolve this, we have to ensure that the SQL batch is properly separated by go command and the view creation is syntactically correct. Alright, so we haven't used the go command here to do that. We just simply, after we have inserted our records in the table, here you just type go, okay, and so this is the end of the first batch. And now since we have created a view in a new batch, we'll just mention this whatever command we have already given, and at the end of the second batch we'll again write go. Okay, and now next I want my query to be shown here, so I'll just write this command for generating my output, which is select star from and the table name. Okay, not that student details table name. I want the view table name to be shown, which is detail view, right? This is the table name. So here, just copy it from here. Just paste it. Just give this semicolon. So now you can see our view is created. So why have we used go? Because go ensures that to create view command is executed in a new batch, and this will help the SQL Server properly separate commands and avoid conflict. Alright, and we have also used the select star from details view, which will fetch the data from the view and includes only student with student ID less than 5, which is Dhanraj, Pratik, Ashish and Harsh. Okay, name and the address is displayed over here. So this is our output generated. Now let's talk about managing views and updating the view. Let's say later on you want to update the view to also include the student's age. Instead of deleting or recreating the view, you can use create or replace view to update it. So let's add the age column to the table now. So we have to just insert the data for the students here. So to add a new column age to the student's detail table, we need to use this command, which is alter table, and then provide the name of the table, which is student details, add age, and the type is integer, and give the semicolon over here. Alright, and now we have to insert the age data for the student. So to do this, we will use the update command, and here we will just write this update. Okay. Name of the table, which is student, and here we use set age is equal to 19, where SID is equal to 2. No, sorry, with SID is equal to 1. So in a similar way, you have to just update all the table over here. So after updating it, you can just simply search run here. So like this, you will just update the student details and set the age accordingly. And now the next step is, after updating it, we have, as you can see, we have just entered all the age number which we want to be displayed here. And we have used the insert to command to insert records into the table with the age values. And now in order to select it, we will give the command which is select star from and the name of the table which is student details. And now if we want to end this batch, we have to use this go command, enter. So now as you can see, we have updated and inserted all the age data for the student, and we have selected all the data from student details to display the final result by giving this command which is select star from student details, and this is the name shown over here, and here is the address, and this is the age. So we have inserted all the age data, and we have also corrected the update statement. Set age is equals to 19, where SID is equals to 1, and do not forget to add this go. Okay. Now the next thing which we will be talking about is deleting a view. In order to delete a view, you just simply have to give this command which is drop view if exists, and then give the name and the table name which is detail view, right? And just simply you can go to this, just run, and you can see that our table has been dropped. Okay, so now we have deleted our table just by giving this command now. So, and do not forget that this command will delete the view, but don't worry, the data in the original student details table will not be affected. Only the view table which we have created is deleted. And now next we will be talking about listing all the views. Okay, so now in order to list all the views, just you have to simply write this command which is show full tables where table type is equals to VIEW, view. So by doing this thing, this output will give you all the views which we have created in this table, the name, student ID, okay, and the addresses, and also the age. Okay. So it will give you all the view table which we have created. Now let's move on to the main part, which is the types of views in SQL. Now let us first understand what is a simple view. So a simple view is created from a single table. It's straightforward and it doesn't involve complex logics like joins or subqueries. For example, to create a simple table, you just simply have to write this command, which is create view student names as, and then select name from student details. Okay, so if you query this view and then write select star from student names. Okay, so after doing this thing, you just simply click on run. So after we have written this view, simple view, which is create view student name as, select name from student details, and do not forget again to mention this go, and then select query the simple view to display student names and select star from student names. Alright, and at last again add this go, and here this is the output generated. the names. Alright, so by using simple query, you can do this thing. Now let's move on to the second part, which is creating a complex view. A complex view involves multiple tables or complex logic. Let's say we have another table known as student marks that stores student marks. So let's say we have created this table student marks, and we have given the details here, and again we have inserted the data values, student ID, marks 193. These are the values which we have inserted. This is the student ID and these are the marks which we have given. Alright, so now let's create a view that pulls data from both student details and student marks. So now as you can see, we have created a complex view by providing all these details, and this is the student ID and the marks shown over here. Alright, so now let's move on to the third part, which is read-only view. So a read-only view ensures that no one can modify the data through the view. This is useful when you want users to able to see the data but not change it. To make the view read-only, you can use permissions in your SQL databases, and this feature depends on your database engine. To create a read-only view in SQL Server, we cannot directly enforce read-only behavior with the create view statement. However, you can control access to the view using permissions. So here's how you can do it. So first you can create the view normally. You can use revoke, insert, update, and also delete permissions from users for that particular view, ensuring that they can only read the data. So now this was all for the read-only view. Let's move on to the fourth type of the view which we are discussing today, which is the check option. So with the check option is SQL, which is with the check option. I'll just type here with check option. Okay, this is the fourth type of view which we are talking about with check option in SQL. It ensures that any insert or update operation performed through a view complies with the conditions specified in the where clause of the view. This means that you cannot insert or update records through the view that violate the condition of the view itself. So let's go through the creation of a view with the with check option and provide an example with an explanation and expected output. So now as you can see, we have the expected output for the valid insertion using this command, which is with check option. And with view creation with check option, we created a view named sample view, as you can see here, that selects student ID and name from the student details table, but only where the name is not null. Alright, so as you can see, we have clearly mentioned here not null, and the with check option ensures that any insert or update through the view must comply with the condition where name is not null. And the first insert into sample view inserts a student where student ID 6 name, which also has a valid name, and here is the output generated here. Alright, this is the student ID, the name over here, and that's it. So now we have learned about this with check option as well. Now I'll be talking about a materialized view. So what exactly is a materialized view? Well, a materialized view is different from a regular view because it stores the actual data in a database, meaning the data is pre-computed and doesn't need to be fetched from tables every time you query it. This makes accessing data from a materialized view much faster, especially for complex queries. Alright, so as you can see, we have created the table and we create three tables: the order details table and the product details and also the customer details table over here. And then we have provide the necessary data also. The second step was the sample data is inserted into all the three tables. The materialized view fast order summary is created to summarize orders, joining data from the three tables and computing the total cost. And the next step is the materialized view is queried, and because the data is pre-computed, it returns results very quickly. With new data, when added to the order details table, the materialized view is refreshed using refreshed materialized view to include the new data. Alright, I hope you get it. Why are we using the refreshed option? And the next step is the materialized view is deleted using the job materialized table over here. We have used this drop materialized view, fast order summary, and in this way you can, create a materialized view. So now you might be wondering that what is the difference between the materialized view and the complex view and the simple view. I'll be seeing you that later. So first, let us now discuss why are views so useful. Okay. So why are views so useful? By now you might be wondering what's the big deal with the views, and here's why it's so useful. They make our life easy. You don't have to keep writing complex queries over and over. You create a view once and it saves you tons of time. They also help you in simplifying data. Instead of pulling everything from your database, views can help you narrow down exactly what you need. They also help in improving security. Want to show only certain parts of the data to certain people? Use views to control what others can see without letting them touch the raw data. You can also rename columns for clarity. You can rename confusing columns in the view without changing the original table, making it easier for users to understand the data. So let us now discuss the differences between the simple, complex, and the materialized view. So here's a quick summary of the differences. So simple view pulls data from a single table, no complex logic or joins involved, and it doesn't store data. It also, the performance is it executes every query every time. Whereas the complex view, it combines data from multiple tables using joins, aggregates, or other complex logic, and it doesn't store data, executes query every time. And talking about the materialized view, it stores the result of a query, making it faster to retrieve data without running the query again. It also stores data and it is much faster as it uses pre-computed data. So now it's time for the quiz. Here's a quiz question for you. What is the key difference between a regular view and a materialized view in SQL? The first option is regular views store data, but materialized views don't. Second option is materialized view stores data, but regular views don't. C, both regular and materialized view stores data. And number D is neither of them store data. So if you want to answer them, you can just write them in the comment section below. And that's it. Views are an incredible tool in SQL that can simplify your queries, improve security, and make your life easier.
So, SQL Server is a powerful relational database management system developed by the Microsoft, which is widely used for managing and storing the data. Its benefits include high scalability, robust security features, and seamless integration with other Microsoft tools and technologies. SQL Server provides efficient data management through advanced features like indexing, full text search, and in-memory processing. It also offers excellent support for large datasets, making it ideal for enterprise applications. The built-in business intelligence tools help organizations gain valuable insights from their data. SQL Server's high availability and disaster recovery features ensure continuous operations with minimal downtime. With strong data integrity and transactional support, it ensures reliable and consistent data management across all applications. That's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. So in this session for today, which is SQL Server tutorial, we will cover the SQL basics. That is how to create a table, how to insert data, how to retrieve the data from the tables, etc. And apart from that, we will also go through some of the other fundamentals of SQL Basics, which include sorting in SQL Server, and followed by that we will also go through the group by and order by sequences in SQL Server. Next ahead, we will also learn another important part, which is conditional statements, which includes case statements in SQL. Proceeding ahead, we will get into another segment of today's session, which is about joins in SQL, where we will be combining two or more tables in SQL Server. Followed by that, we have the next part of today's session, which is all about the having clause in SQL Server. Next, we will proceed with learning the next part, which is about the between operator in SQL Server. And followed by that, we will get ahead with pattern matching in SQL Server. Next, we will cover the time and date functions available in SQL Server. And after that, we will proceed with temp, which is temporary tables in SQL Server. And proceeding ahead, we have the most important part, which is about the common table expressions in SQL Server. And followed by that, we have the last part in SQL Server tutorial, which is about creating views and executing a query to extract the data present in a view in SQL. So far, so good. So these are the foundational skills in SQL Server that you need to get before becoming a pro in SQL Server. So this particular tutorial will discuss the major foundation skills, the fundamental skills, the basics of SQL Server and its operations. Now, without further delay, let's get started with one of the compilers which can help us execute the SQL Server queries. So we are on one of the SQL Server compilers available online. In case if you are facing any difficulties setting up the SQL Server Management Studio in your PC, then you can come up with this one. And we've also set a particular tutorial where you can learn how to download and install SQL Server Management Studio and how to configure your SQL Server Management Studio. And the link to that particular tutorial will be dropped in the description box below. Make sure to refer that in case if you wanted to execute these same codes in SQL Server Management Studio, right? So first we will be dealing with two different data tables. We will be dealing with customer data and dealership data. So the first table will be about the customer data, where we will be having about the order ID, order date, delivery date, dealership pin code, product category, and car fuel type, etc. Followed by that, we will insert some rows into that particular customer table, about 15 to 20 tables. And after that, we have a dealership database where we will be having order date, state, region, customer ID, customer name, primary key, foreign key, etc. And we will be inserting about 20 entries into that particular table. Don't worry if you have more than 20 entries. In case if you have more than 20 entries, let's say about 2,000 entries or 20,000 entries, it's not at all a big deal if you're working on SQL Server Studio, right? There you can use the wizard to just ingest the data from your source into the SQL Server, right? You can use SSIS tool to import all that data and you're good to go. You don't have to manually create the data and you don't have to manually insert the data. Just for the sake of learning the basic process of how to create a data table and how to insert the data table, you're going through this particular procedure. So far so good. So we have also inserted the data in the next data table, which is our dealership data. And now let's query the data from our tables. And now let's select the execute data. There you go. We have the data table right over here. And let's copy this query and paste it to query the data from the customer table as well. So instead of dealership, we will be writing down customer. So if you observe closely, I'm using uppercase for keywords like select and from, and sentence case or lowercase for the variables, the table names, etc. So that there's a difference between the keyword as well as the regular variables. There you go. We have executed the customer data and here we have it. The order ID, order date, delivery date, days to deliver, category, and etc. Now, let's mention the use cases, correct? So let's use double quotes, or maybe we can also use hashtag along with the pipe symbol here or the slash symbol here and write the use cases and then proceed with executing the codes or queries. So the first use case is let's try to filter customers from specific regions. And now let's close this particular comment, proceed with writing the query. So we will be using select keyword and we want customers from a specific region, right? So let's write down the customer name. So I think the customer name is not mentioned in the customer data, but instead of customer name, we have a order ID. So let's extract the order ID, not a problem. Select order ID and dealership name, comma state, and the important part, which is about the region and what product did they, and what's the revenue that the dealership has extracted out of that particular customer from the table customer. Next line is about join dealership. So we will be using join table dealership, the keyword. So we have one common keyword in between both the tables, which is about the order ID. which is equals to order ID. So this is not done here. Since we are clubbing both the tables, we need to specify the tables here. So dealership dot order ID and customer dot order ID, so that the SQL Server will identify we are trying to map two different tables, and we are trying to combine and extract the data. Now we are trying to filter out customers from a specific region, correct? Now we will be using where clause to specify that particular region. So let's go with West region, correct? Since we are using the text format here, so it's better we choose double quotes, correct? Now let's run this query. Let's give it a next try. Ambiguous order ID. So let's do one thing. We will pull customer table name here so that it's no more ambiguous. There you go. So the thing is, we have order ID in both the tables, customer table and dealership table. So SQL Server got confused here, which particular table you want me to extract order ID from. So if you mention customer table or dealership table, it will choose a specific table and extract that particular column. Now we have the order ID, dealership, and all the members that we selected are from the West region, if you check here. Now let's proceed with the second use case of today's session. Okay, let's continue with the same here so that it is clearly visible for us. Now, let's sort, we're using the sort command here, products based on the revenue. So it's like maybe highest revenue should be in the top or lowest revenue should be in the top. Let's go with the highest revenue, okay? Sort products based on or based by revenue. We will write the command here itself. We will go with some columns. I would like to have product here, so I'll eliminate everything else, and the product will be here, and I want the revenue as well. Now I don't want the revenue, I want the total revenue. So if you're looking for total, then you will be going with the function or aggregate function, which is sum, right? I want the sum of all the revenues that particular product has earned throughout the years or that particular financial year. From which table? So I have both product and revenue in the customer table itself. So I'll go with customer table itself. I don't want to join anything here. I'll eliminate the join command. And instead of region or instead of where command, I would use the group by command here. Group by product. And it is not done so far. We want to order it. So we want to keep it in descending order so that the highest grossing product is on the top and the lowest grossing product is on the bottom, right? So that we can also make sure that our inventory is filled with those products which are giving us high revenue. So we will be using order by total revenue, right? So we can give it an alias as total revenue. Right now we can use this particular term here, order by total revenue, descending. DESC is good enough. Now this is how you will sort the products. Now let's execute this particular query. There you go. So the car model T, okay, yeah. So the car model J is giving us the highest revenue. Next is followed by T, M, and S and G. So we are not mentioning specific, if you go back to the table, here we are not mentioning the actual car brands and actual car names, so that we don't want any copyrights to be faced. So we are just mentioning some random names, not to be too specific there. Now, let's proceed with our next query for the session, where we want to group by state and calculate total revenue. Let's edit the same comment here. Don't worry, if you want this demo document, we will also link that demo document with all edit and view rights so that all the viewers can have a quick glance and try to execute these queries in their own local systems. Okay. Now let me type down group by state and calculate total revenue. There you go. Now let's try to edit the same query. Now we want state-wise revenue and we want from customer table, right? We want to join a dealership for this particular one because dealership is the one which has some details for it. So the state data, right here you can see we have inserted state data California, Texas. So we want the state data, so it is present in dealership table. So we also want to perform a join there. No worries, let's edit the same query here. So we want, instead of product, we want state. And instead of sum of revenue, we want revenue. So we will keep it as it is, total revenue as total revenue, sum of revenue as total revenue from customer table. And we want to perform a join operation. So let's create some space, join dealership. Okay, let's copy the name so that we don't make any confusions here. Dealership, sorry here. Don't worry, we'll make some edits down the line. Dealership on order ID. So let's go with the order ID, which is available here. Order ID equals to order ID. Remember the first step we did. Eliminate the confusions by mentioning the table names, dot column name, and customer name. The customer table name, dot column name on. Yeah, we did it on dealership dot order ID equals to customer dot order ID. Now we will be performing the group by operation. We don't want the order by here. Group by state. Of course, in case if you wanted to, order by the highest grossing state, you could have used order by there. But so far, according to the use case, we don't want that. So let's continue with the same execution here. Click execute and you will be having the answer here. So based on the states, you have their respective revenues. There you go. Now let's proceed with the next use case for today's discussion, which is about using a conditional statement like case. Using case, query, or clause for custom calculations. We'll perform some customized calculations. Now let's say we wanted to find out a product which is giving revenue greater than 10,000 as high revenue. Let's say we have revenues in terms of thousands of dollars, and let's have a benchmark like $10,000. And $10,000 is the minimum revenue you wanted to extract out of that product. And if it is not yielding at least 10,000 for your dealership, then that product is not selling much. So that you can at least make some space in your dealership so that you can import some products which are giving you highest revenue, right? So we want to find out those products which are giving us revenue between 5,000 to 10,000 as medium revenue, and less than 5,000 as low revenue, and greater than 10,000 as high revenue. You understood the game, right? So we have three segments: high revenue, medium, okay type of revenue, and least revenue products, so that you can eliminate the least revenue products out of your inventory. Now we want order ID. So copy the order ID from here and paste it here. So we are looking for order ID and we are also looking for product. So we don't want sum of revenue here. Let's eliminate this one, and instead of that, let's add product. From we'll extract this from, okay, before from, this from statement will be at the last. Here we will begin with a use case, right? Let's type case. Now, when a specific product or revenue, okay, revenue is greater than $10,000, then let's not use sentence case, let's use keywords in caps. Then mention it as high or high revenue. Let's copy paste the same code here. When revenue is between 5,000, and we will be using an AND operator here, then term it as, okay, we don't want alter, average revenue or medium revenue, and copy paste the same here. We'll remove the alter. And revenue is less than, okay, I think we don't want to use this. Instead of this, we can just place else, right? So we will place else, it should be termed as low revenue or least revenue. Let's go with low revenue. There you go. And now from which table you want to extract that? I want to extract all this data from customer table. So everything will go off apart from that. Now let's execute this particular code. Let's see if we get any errors. Incorrect syntax for case. I think we made some mistake here. Okay, we forgot the comma here. Should have mentioned a comma. And yeah, so the thing is, we by mistake chose the alter from suggestions, alter keyword from suggestions. So far we missed a comma and alter from suggestions. I think it's everything good to go. Let's try to execute, and if it faces some issues, no problem, we'll try to resolve it in a different way. So incorrect, we missed to write the end. Okay, we did not end the case. Okay, fine, not a problem. End as, okay, let's term it as the entire table as revenue category. Since we are splitting into 3 categories, revenue categories. There you go. So this is the way to learn. Make some mistakes so that you can learn in a better way. For the next time, you'll never make a mistake. So far, so good. So we have all the car models have categorized into the revenue categories: high revenue, low revenue. So far, we have all the cars in high revenue. Not a bad deal. I think all the cars are performing really well. Maybe if we change the numbers a little bit, maybe if we take up 1 lakh in place of 10,000, then maybe we can get a couple of cars. But so far, so good. This is how the query works. Now, let's switch to our next query, next use case, where we will be combining data from multiple tables using a join. We already did that, but still, for the sake of learning experience, we will also perform that particular operation. So we will be naming this particular use case as combine data from multiple tables using a join. So far you have already have a good experience on how joins work, but still we will try to do that. Now we will use customer table here, customer table dot order ID, and we want customer table dot product and customer dot revenue. And, let's also say take some data from dealership. So we already know that some data of states is in dealership, so we'll also take the dealership data. So dealership dot state. We'll also take the region, dealership dot region from customer table. Let's eliminate the case statement from customer, and we want to join. Let's push this to the first line so that we don't have confusion how and where the query is going on. So here I want to join. So the second line is all about join dealership. So let's copy this. We are combining dealership with customer on order ID. In the same way, we will take order ID equals to order ID. Now, which order ID is equals to which order ID? The first table, customer.order ID, is equals to the second table, dealership order ID, so that SQL Server understands which columns from which tables are being joined here for what reason. Right? So far, so good. We have given the columns that we want to have in our output, which are these columns, and we are joining 2 tables based on certain criteria. But now, maybe we can specifically mention some more data. Let's say we already mentioned some query where we wanted the data for a specific region. Let's try to continue that, where region is equals to West. There you go. Let's close the single quote or double quote. Now what happens is it is trying to give us the details of customer order ID, product, revenue, state, region from customer table. And we are going to also execute or extract the details of state and region from the dealership table, and we are trying to join to extract those data with dealership data. And we are specifically extracting the data where the region is West. Let's execute the data. Don't worry if we find any errors in this particular code. There you go, we have the result. So we have all the details from the West region. There you go. Let me expand this so that we have a better view. Anyways, it's okay. Now let's go with the sixth query for today's session, where we will be executing a query based on having clause in SQL Server, and we will try to filter out some states. Only show the states where total revenue is greater than 50,000, just like we discussed before. We initially used a case statement with $10,000 at least revenue, but now let's increase the number to 50,000, and we want those states which are giving us minimum 50,000 revenue. So let's rename the use case here. We will try to name it as filter data or groups with having clause. Okay, so we want state. We have state here, and let's also count as total orders. So order ID. So customer.order ID will be now count of total orders. So the count will be the aggregation function here, count total order IDs, and we can name it as total orders. And do we have revenue? Yes, we have revenue. And let's also remove the product. I don't think we might need a product here. And the aggregation will be sum aggregation here, sum of revenue. And I don't think we need to specifically mention it here. But anyways, we'll keep state first. Copy state and drop it here. We want state count of orders as orders and sum revenue as total revenue. What this does is it will give a clarity, right? So instead of if I don't alias it, what it shows is sum of revenue. And for a generic person, it might not be as helpful as a data engineer can, right? For a data engineer or data analyst, he can totally understand by just reading the aggregation function. So we are counting the orders here, we are getting the sum of revenue here. But for a mere person who just wants to see the report, the business guy who just wants to see the report, for him, total orders or total revenue is a simplest language that he can understand, correct? Now we are extracting this data from customer, and we will join dealership again, okay? Because we also want to extract the state, right? So we did not mention the state here. We can mention the state anyway. Okay, we did mention the state. So since we have the state column, for extracting state details, we'll anyway go for the dealership. So we are already joined with dealership data with customer data. And let's do a group by function here. Group by region, group by state actually. And now the condition, having sum of revenue at least or greater than 50,000. So we will go with the having clause here, and the sum of revenue, or you can also use the alias name, total revenue greater than $50,000. So let's execute this query and see if the alias works or not. Okay, I think alias will not work here. In case of alias, let's go with the actual term and place it over here. And now let's try to execute this if it works or not. Okay, we mentioned two things here, region and the state. So we just wanted state there, not region. I think this should solve the issue. 20 rows affected. Ambiguous column, order ID. Now we will, let's say, take customer name and place it here. Or I think a dealership would be the best, because we have the details of orders here. No. Customer table has the order details. So let's keep it that way. There you go. So we have so many number of states which have revenue greater than 50,000. So these are the outputs. There you go. Now let's proceed with the next query, where we will be using the range function, which is also known as the between function in SQL Server. So let's name the comment as using the range function. Let's not capitalize it. Using the range function named between. So between is the keyword, right? Now let's build a use case. Let's identify couple of states. We will use the same query, will not make some major differences here. So we want to identify a couple of states whose revenue is greater than 50,000 but less than 1 lakh, right? This makes a good use case for that implementation of between function. We will keep all the columns as they are, and maybe we can also include a couple of columns, maybe product as well, and we will join two tables. Now I think we don't need a group by here, but in place of group by and in place of having, we will specify where sum. So to use where clause, to use between clause, having is not the right keyword, where is the right keyword. So sum of revenue should be, in place of the symbol between, you take the suggestions, and 1 lakh. Yeah, this is 1, 2, 3, 4, 5 zeros. So this is the right way. Now let's try to execute if it works or not. If there is some error, yeah, there is some error. An aggregate may not appear where clause unless it is subsidiary. Okay, contain having clauses select. I think this is the place where we can go with the alias name. Let's try that. Or if alias does not work, then we will go with the revenue. Okay, let's simplify this. Let's not go with the join statement here. Let's eliminate the join. We shall just simplify. We don't want state. We want, okay, let's not count this. There was no need for counting. I think that was one error. We will go with order ID as total order. We don't want this. And anyways, we want to take a look at the product and dealership name as well. And we also want revenue from customer table, where revenue is between these numbers. Let's try to simplify and run this query. I think it should work. Yeah, it worked. So these are the dealerships and products which yield in revenue between 50,000 to 1 lakh, right? So this is the best way to use it. So we had some extra aggregate functions which complicated the query. No problem. Now let's go with some pattern matching. Sometimes, let's say we are looking for sales from California or something like that, or we are looking for some car model, correct? And we don't know the full name, or we might have a spelling mistake, right? We have California here, but let's say we don't know the spelling of California, but we know the first 3 or 4 letters of California, right? So in those instances, what you can do is try to match the pattern that we have in our hand with the pattern which is available in the data table, and wherever it finds a match, it extracts those rows. So this is how the pattern matching works. Now let's execute a query for a better understanding. Let's keep the same query. Let's change the use case here using the pattern matching in SQL Server. So we will have order ID as it is, dealership name as it is, and product as it is from customer table, where product, so let's copy this and paste it here, like, or I like is the opposite, so let's go with like. Car model, let's check with the car models first. So all car models are the same. So maybe if we go with the fuel type, I think fuel type will help, because all the car models have the keyword car model, and the only thing is an alphabet M, etc. So it doesn't make sense for us to execute the like operator here. So instead of product, let's keep fuel type like hybrid, correct? Let's go with the hybrid one. So we will take only the first 4 letters. Let's imagine we don't know the full spelling of hybrid. So if the pattern is like, and since it's a text, we will use so single quotes or double quotes. If the pattern HYBR matches with the elements or the column present in the customer data, it will pull all those columns or rows. Now let's execute this. So there you go. Okay, we missed one important thing. We missed to include the percentage. This percentage symbol will make SQL Server understand that the text should have HYBR, and after that anything is accepted. So anything which has a beginning with HYBR should be pulled out, right? Now let's execute once again and see the data. There you go. You have it. Correct? So remember the symbol percentage, right? And in case if you didn't knew the hybrid, let's say, it has some YBR in its format, right? It has some YBR in the format. Anything before YBR is okay. Anything after YBR is okay. Again, it will yield the same result, hybrid. There you go. But in case if you wanted to change, let's write the name of petrol. I don't know the spelling of petrol, so let's say PEET. So let's imagine I don't know the name of petrol, so instead of petrol, I'm eliminating P and I'm writing PETR and anything after that. Now let's run this query and see the output. There you go. So we have all the vehicles which are of fuel type petrol. So this is how you can use pattern matching in SQL Server. Now let's perform some calculations with dates, right? So we'll perform some date and time calculations. Let's rename the comment as date and time functions. Date and time in some math calcs. Now, let's say you are the owner of dealership, and let's say for a specific car you are losing customers. Initially, it used to perform very good. Like many customers used to come for that specific car. And right now, that specific car is receiving less orders. And you wanted to find out what is the reason behind it. And after a general survey, you come to know that the number of days you took to deliver that car is growing. Let's say earlier you used to deliver that car in 2 days. But right now, you're taking like 2 months to deliver that car, right? So that might be the reason. But you wanted to make sure that you have a solid proof that you have the number of days that you're looking at to show your sales team why is so many number of days is being taken to deliver a car. Now for that, let's go with select order ID, order date. You want order date for it. Now you can simply copy the order date here and paste it there. And you also want the delivery date and copy that and paste it there. Remember, these date and order date and delivery date are of date data type. And now you want to calculate the difference. So for that, you use a function called dateDiff or datedDiff. So there's 2 ways of calling it. So if you prefer calling it as date, right, diff, or a few call it as datedDiff. Okay. So there's 2 ways of calling that function. So I prefer to call datediff because date difference. So datediff, comma, open bracket. So I want to provide some details here. So I want to provide a day. I want to count the days, right? So I want the count of days. I'm mentioning day and order date, difference between the order date and the delivery date. You can specify that using a comma. So I want the difference between these two. In case if you want to alias it, you can also do that. Days to deliver from customer, and we don't want this. Simply place a semicolon there. And now just copy this and execute. There you go. Now you have the number of days that you or your sales team is taking to deliver the vehicles. So, and on an average, you're taking about 10 days to deliver. Now you can prove this to your sales team and let them know this is not good. You want to have at least a minimum 4 to 5 days or 2 to 3 days to deliver a vehicle. If this goes on, the sales might drop and it might be a little problematic, right? Now let's proceed with the next use case of today's session about the temporary tables. Now, why temporary tables? So there comes a situation where you have to just run some numbers, run something very not too critical, but you just wanted to do that. So in such scenarios, what you can do is you don't want to harm the original table. So what you can do is you can create a temporary table or a copy of that table, which is somewhere in the intermediate memory storage. And as soon as you close the studio, it fades away and nothing happens to your original data table. So that is where the temporary tables come into picture. Now let's create a simple use case for that particular temporary tables, right? So we will be selecting order ID, and let's also take product, and let's also take revenue into temp order. Yeah, it's enough. Temp order tables. I don't want that. Temp order, and I don't want to alias it. And from which table are you taking that? I'm taking that from customers. You can either choose to keep it in a new line, or you can keep it in a same line, but I want to keep it in a new line. From customers, and where revenue is, I said you right, you wanted to just explore a few things which is not too mandatory, but you just want to take a look at it. That's why you take the option of creating temporary tables. And I want to find out which are those products which are giving us revenue greater than 1, 2, 3, 4, 5, $1 lakh, right? Now let's run this. It's done, but we don't know where it is. So what you can do is you just write up simple select query, select star from your temporary table. Close the query and run it. There you go. So far there are no such products which are giving us greater than 1 lakh sales about that single product. Invalid object name, temp order. Okay, there might be some error about this particular query. Let's try to reduce the number. Did we miss anything? Where revenue is greater than, okay, this is a number, we don't want semicolon there. Okay, we missed a semicolon here. Let's run this, execute. Let's keep it as 10,000. Okay, so there was no certain product which was above 1 lakh. That was a problem. Okay, so these are the products which are giving us 10,000 sales at least. Not a problem. Now let's proceed with the next important part of today's session, which is about the common table expressions. So remember, common table expressions are also known as CTEs, play a very major role in real-time data analytics. Right, so let's have a sample of that. Let's create a common table expression, which is rather simple, and just learn how technically it works. Right, so the only difference is the CTEs start with a keyword named as with, and after that you can term your common table as some data. So or some name. I'll give it as sales data as, and open a bracket, and inside this bracket is where you write your actual query. Now let's organize a few things. I don't want the temp order table here. I don't want temp order here. Okay, I want to extract a few columns. I want maybe state, and I maybe want I don't want order ID. I want revenue. Maybe revenue is good. So let's sum the revenue and term it as total revenue from customer. And now let's proceed with a join command where we will be joining dealership data. Let's copy the dealership data table name. We will be joining based on the order ID that is common. So maybe order ID. Copy the order ID is equals to order ID. And which order ID are you talking about? I'm talking about customer's order ID and dealership data order ID. So we need to mention that on dealership.order ID and customer.order ID. Group by state. So since we took state as well, we can use a group by function here. And this is not the end of everything, so semicolon may have to wait. So this is the first part. Now, using this particular CTE, this entire term is CTE. So the output of this particular query will be stored in sales data. Now, we will make use of this CTE or sales data term to extract a few more queries. So we will be writing another select statement. Select state from, okay, let's also take the total revenue which we created here. Let's take that same term here so that we don't make a mistake. From the CTE which we created very recently, which happens to be the sales data, where total revenue is crossing something about $50,000. And now is the semicolon. Let's try to execute this. There you go. So a few regions or a few states and total revenue which are exceeding $50,000 are, there you go.
What is PostgreSQL? PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released. And in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux and Mac OS. It is highly secure, robust and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string and boolean. It supports structured data types such as date and time, array and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we will see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with 2 brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay. Now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependents, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database which was SQL demo. So let me show you how to work on this pgadmin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom, and it says PostgreSQL 13.2 compiled by Visual C++. It has a 64-bit system. Okay, now let me tell you how to perform a few basic operations using PostgreSQL commands. So here let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question mark will deal with this later. Alright, Let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell, and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards. So there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb rating. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the PG admin. So here under tables, I'll right click and I have the option to create a table. So I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name, and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here at the bottom you can see we have the movie ID, the movie name, movie genre, and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students, you can write drop table students, and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name, and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre, and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie, which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \d and the name of the table, that is movies, This will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constant or primary key or foreign key and others. Let me go back to my PG admin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. Go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, comma, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where, let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The Seven, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. So you can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into two lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies, where let's say the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright. Like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL_demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values, so I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size as 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table, and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import underscore export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright. Now, as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here, for all these employee names, there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID. And if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table. So I'll write select star from employees order by. I want to order the employees based on their salary. So I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here, if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here, I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator and let's say you want to know the employees who are from country Germany, or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of and I'm going to use or, their department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows written by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information, and these are the top 5 employees that have the highest salary. Okay, so this is one method of, or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here, and here after descending I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows, and you can see the top 3 employees that have the highest salary, since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright. We have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials. So you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column, employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is, instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here, instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is, I'll copy this and instead of a%, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum, and inside the sum function I'll give my column name that is salary from my table name that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG and I can edit my alias name as well, let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum or max, which is the function name of salary, as let's say instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay, so now let's update our department column. So what we are going to do is wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by. Since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany. And on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees, group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select. Since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp underscore id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country. So group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay. Now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay. Next, we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL, the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say, salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement. But before that, let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column, I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase, or in sentence case. Similarly, I can write case as small c, or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this, we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column, that is salary range, and I'm specifying the range. So I have three conditions here, for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have ordered our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We will compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright. Now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the / an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this, so I'll give another asterisk and a /. So this is also a comment in PostgreSQL. Alright, so first of all we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, -100, it is going to return me +100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was -100, the absolute of -100 is +100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers, let's say 4, 90, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case, 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now, like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2, because 2 is the least number that is present in this selection. Alright, now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power, let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say power of 5, 3, it should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here, 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. Let's scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I am going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string. Now let's say I want to combine PostgreSQL I'll give a space, comma, I want to merge PostgreSQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right, and mid in PostgreSQL. So what the left function does is, it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left, and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is, it will count 5 characters from left, so 1, 2, 3, 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay. Now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say, India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here. India is a democracy has been printed in reverse order. There you go. Alright. Now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay. So let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function. Then I'll give my function name as count emails. And as you know, functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select. I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon and then we'll write return total emails. As you know, user-defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language as PostgreSQL. So the way to mention is PL P G SQL. Let's give a semicolon and end it. So this is my user-defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and or operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions, and finally we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL. Now if you want to get this SQL file that we have used in the demo, you can give your email IDs in the comment section, and our team will share this SQL file with you over email.
So, what exactly is a CTE, you ask? Now, if you are a beginner in SQL, let's say you wanted to club two different tables or more different tables, maybe 3 or 4, right? So you will be using one keyword, which is join, right? And let's say you may have to create a query in such a way that you have to club different tables and you have to extract the results from one table into another and finally create a output table, right? So this might be sounding a little too complex. So basically what CTE does is it acts as a temporary table, right? Now you can write a query and save it as a CTE, right? And that particular resultant table from CTE will not be created, but will be in the memory as a temporary data or an intermediate resultant data, right? Now, whenever you want to use a join, or whenever you want to use the same query inside a bracket or inside something in your query, you can just simply use the name of the CTE and then the data you require, the columns you require, and done. You will get the data. Now, this might be a little too complicated to understand in just mere words. Now, let's just go through the formal definition of what exactly is the CTE and what it does, and then let's quickly. So, it's a little too complicated to understand it just with mere words. So, let's get started with the practical examples. But before that, let's understand a formal definition of what exactly is a CTE in SQL. So CTE, also known as or also called as the common table expression, or some people also are used to call it as a with expression. So the keyword is with. So a common table expression in SQL is a temporary result set that you can define within a query. As I said, it helps to break down the complex queries, make the code more readable, and allows you to reuse the result set multiple times within the same query. Just you need to use the name of the CTE in the places where you want in your query, and it reduces the code length as well as the execution time. Now, CTEs are defined using the with keyword as we discussed before, followed by the CTE name, right? So for every column name or anything in your dataset, you give a name, right? Similarly, when you are using CTEs in SQL, you also need to give a name to the CTE, and that particular name will be used in your subquery positions that will reduce the query length and execution time. So you should be giving a name and the query that generates the result set. The CTE is available only during the execution of that particular query or specific query, right? So as I said, the CTE table, the resultant table which is created while you are using the CTE, will not be created as a permanent table in the database, right? It will be a temporary or intermediate result which will be active as long as your current query, which is using the CTE, is active. Now, let's go to the demonstration mode where we will try to create some simple queries, right? And we will understand how exactly a CTE can be beneficial in those situations. Now, let's go to the MySQL workbench. This is my MySQL workbench. So I have a lot of tables here. We have the credit card dataset, we have the Sakila dataset, SLP dataset, says Superstore World, etc. Right? So we will be using the Superstore dataset. The database. So firstly, we need to write in the query, which means that I am going to use the Superstore database, right? Sorry, Superstore. So I prefer using smaller case or lowercase for database names and column names, and uppercase for the keywords. For example, here use is uppercase and Superstore is the name of the keyword, right? So that is for identifying or easy readability, which is a keyword and which is a name, right? So let's execute this query and have access to the Superstore dataset. And in Superstore dataset, I have one table called as Excel data. Now let's quickly check what we have in Excel data. Select star from Excel data. Here we have row ID, order date, ship mode, customer care, everything, right? So we have region, we have sales, quantity, discount, profit rate. So we have a number of possibilities, a number of reports that we can generate. But let's try to keep it simple. Let's try to find out unique regions, right? Select unique of regions, right? Or just regions, Excel data. Group by regions. So let's quickly execute this statement and see the output, or maybe we can make some modifications to it, right? Instead of that, you might want to use distinct function so that you don't get all 10,000 plus rows. So basically, this particular dataset has about 10,000 or more rows in it, and it's not real. It's completely made up report using artificial intelligence. So we use ChatGPT to create 10,000 rows of data for 30 years, maybe from 2000 or 2001 to up to 2030 or 31, right? So we don't want all those 10,000 plus columns, sorry, rows. So let's use a distinct here and try to execute this statement so that we get 5 of the regions what we have. So there you go. We have 5 regions as expected: northeast, southwest, and central. Now you can also select a kind of maybe average of sales, maximum of sales, and total sales. So this is bringing us somewhere. We can, try to find out region-wise sales, right? So region-wise sales grouped by years, like 30 years. What was the sale happened in the year 2001, right? We begin from 2000 or 2001 to all the way up to 2030 or 2031, right? So we can see if there is an increase in the year-on-year sales or decrease in the year-on-year sales. We can identify the best performing year, the worst performing year, right? So this sounds like a good use case. Now let's go to the code where I've written it as a CTE and understand the workflow. So here I have named my CTE as sales CTE. So I'm starting it with the keyword with, right? So with sales CTE as. Now this is our query, right? What am I doing? I'm extracting. So according to the dataset, we have the date, right? So the date is year, month, and date of that particular day, right? But we want just the year. So we're using the year function to extract the year from the date as sales year, region, sum of sales, right? We wanted to find out the total sales happened in that particular year as total sales from the dataset, Excel data, and group by year, right? We wanted it in increasing order. So 2000 to all the way up to 230 or 2031, correct? So that's how it is. And I'm saving all this as a CTE named as sales CTE. Now I want to select some parts of that particular CTE. So I want to select sales year, region, total sales from sales CTE, which is right over here, and order it in form of sales and region, right? Now let's try to copy this code and run this in our workbench. Right? Now let me close this quickly so that we have a complete view of the code, right? So let's now select all the code. So now we have selected this particular code. Let's try to run this and see the output. There you go. We have the output, but there is something wrong. We did not get the years, right? So all the 30 years of data, here it is grouped by region, which is fine. Okay, we don't want region, we want to group it by year. That's okay. And the thing is, we need to fix this particular year. So maybe there is something wrong with the order date, right? So I think the database has saved this particular. Oh, okay. Since this is generated by ChatGPT, maybe the data type of the date is other than data, right? Other than data type. It may be string. Now we might have to do some typecasting to change the data type of the order date, and let's quickly do that. So now we have updated the year. So what we have done is just cast here, right? So we have changed the string type of date to the normal date, which follows by year, month, and date. So this is a simple typecasting that you can do, and rest everything. And we've also added a where condition, so where date is not added or date is equals to null, then you can just ignore that. And now let's try to execute this query, and we have also removed that region thing, right? Group by region or order by region. So we want that to be ordered according to the year, which should start with 2001 or the first ever year to the last ever year according to the dataset. Now let's select the entire CTE query and run that and check our outputs. So there you go. So you have the year-on-year sales from 2001 to all the way up to the year 2030 and 2031, right? So that's how the CTE or common table expressions in SQL or the with query in SQL can be used.
Picture this, you are in an interview and the interviewer asks, can you write a query to find the top 5 sales records? You freeze for a moment, thinking, am I ready for this or not? Don't worry, SQL might sound complicated, but it's actually a super useful tool that lets you interact with databases. Have you ever wondered how all those apps and websites stores and organize their data? Well, that's where SQL comes in. SQL, which stands for Structured Query Language, is a universal language for talking to databases. It's super powerful and lets you do things like pull out specific information, add new data, update existing stuff, or even delete things you don't need. It's basically your magic key to manage huge amounts of information with ease. Exactly. And if you're aiming for a career in tech, whether it's a database administrator, data analyst, or software developer, SQL is a must-have skill. Databases are at the heart of almost every application, so knowing SQL can unlock some really exciting opportunities. Now, here's the exciting part. This video is your secret weapon to master SQL interviews. We have packed it with 45 carefully chosen SQL interview questions that cover everything you need to ace those tough questions. So we'll be starting with the basics like how databases work and then diving into advanced query challenges, and by the end you'll be fully prepared to tackle any SQL question thrown at your way. So let's dive in and get you closer to your dream job. So let's get started. So now let's start with a SQL interview question. We'll cover every question starting from basic level to advanced level. So now let's look at our first question, which is very basic. What is SQL? So we all know that SQL stands for Structured Query Language, and it is the language which is used to talk to databases. Think of it like giving instructions to a computer system that stores and organizes data. For example, if you want to find out all the customers who ordered a specific product, then SQL can help you do that with a simple command. You can also use SQL to add new data, like entering a new customer details into a database. If you want to update someone's phone number, SQL has got you covered. Or maybe you want to delete old records that are no longer needed, SQL can handle that too. Here's a quick example. If you want to find all the customers in New York, you could write something like select star from customers where city is equals to New York. So we are using this command to find all the customers in New York. Remember, if you want to find out all the specific data from the table, you have to use the star command. And if you want to add new customer, you can just simply write insert into customers, name, city, and then you can also insert value name, which is John, and you can just enter the specific location. So SQL works the same way across many popular databases like MySQL, PostgreSQL, or SQL Server, which is why it's such an important skill for anyone working with data. So now let's look at our second question, which is what are the different types of SQL commands? So SQL commands are like instructions you give it to a database to tell it what to do. There are different types of commands and each one has a specific purpose. So let me explain these in simple terms. Remember, if an interviewer asks you such questions, simply explain using the proper keywords and use proper definitions and easy language. That's it. So the DDL command we have, which stands for Data Definition Language. It basically defines the structure of the database. For example, if you want to create a table, or if you want to alter a table, or if you want to drop a table. Then we have DML, which stands for Data Manipulation Language. It deals with the actual data in the database. For example, insert, update, delete, all of these things. Then we have DCL, which is Data Control Language. It will manage permissions and access control. So if you want to manage permission or access control, then you have to use this particular type of SQL command, which is DCL, which is grant and revoke. Grant will provide access rights and revoke is used to remove the access rights. We also have TCL, which stands for Transaction Control Language. It will manage transactions in the databases. For example, commit is used to save changes, rollback is used to undo changes, and save point is used to create intermediate points in a transaction. So for instance, in a schema with customers table and an order table, data definition language commands are used to define the table, whereas data manipulation commands, which is select, insert, and delete, it is used to update customer or order data. DCL is used to control access, and TCL, which is transaction control language, is used to manage transactions. That's it. It was very simple. Now let's look at your third question, which is what is a primary key in SQL? A primary key in SQL is like a unique ID for each record in a table. Think of it as a way to ensure that no two rows in a table have the same value. Remember that no two rows must have the same value. It is also a rule that the primary key column can't have empty or null value. So these are the basic criteria for a key to be a primary key. For example, in a table of customers, you have a column called customer ID as the primary key. Then each customer have a unique customer ID like 1, 2, 3 and so on. This makes it easy to identify and retrieve specific customers from database. Here's a simple example. Suppose we have created this table, create table customers, and we have given the customer ID as primary key. We have given name as varchar, the city name as well. So the primary key will ensure that each customer ID is unique, no duplicates are there, no customer ID is left blank, that is there should be no null values, and primary keys are also important when linking tables together. For example, if you have orders table, you can use the customer ID as a reference to connect each order to a specific customer. This helps maintain data integrity across the databases. Now the fourth question is, what is a foreign key? A foreign key in SQL is like a connection or link between two tables. It's just like a field in one table that refers to the primary key in another table. This creates a relationship between the tables and ensures that the data stays consistent. For example, let's suppose you have two tables, a customer table with a primary key called customer ID and a sales table with a field called customer ID, which is a foreign key linking back to the customer ID in the customers table. So here's how it will look like. We have created this table and you can see in this example that suppose we have customers and sales table. So we have used this customer ID in our customer table as well. So here customer ID is the foreign key and in the customer table the customer ID which we had used is the primary key. So now let's move on to our fifth question, which is delete and truncate command. What is the difference between delete and truncate commands? So delete and truncate commands in SQL both remove the data from a table, but then they work in different ways. Let me break it down for you. The delete command. So what delete command will do is basically, this is used when you want to remove specific rows from a table based on a condition. For example, if you want to delete all the customers from a specific city, then you have to use this delete command. It will allow you to be selective, but it's slower because it logs each row deletion, which also makes it possible to roll back the changes if needed, if you're using transactions. Moving on to truncate command, truncate will remove all the rows from a table at once without allowing any condition. For example, if you just want to remove all the rows just in a one go, you have to use this truncate command. Just simply write this query as truncate table. Suppose the table name is customers. Is much faster because it doesn't log individual row deletions and it simply clears the entire table in one go. However, you can't roll back a truncate operation in most databases once it's done. So the key differences is delete is for specific rows, truncate is for clearing the entire table. Truncate is much more faster because it uses fewer system resources. Delete can be rolled back if used within a transaction. Truncate usually cannot. Delete logs each row deletion and truncate doesn't. So this was all for this truncate and delete command. So anytime if the interviewer asks you such questions, just simply explain this. Now let's move on to the sixth question, which is, what is a join in SQL and what are its types? So this is one of the most important questions you'll be getting to know in the interviews. You'll be asked such questions in the interviews. So basically, a join in SQL is used to combine a data from two or more tables based on related column, like a column key that links them together. It's just like connecting pieces of puzzles. Join help you see the bigger picture by merging related data. For example, if you have a customer table and a sales table, you can use the join to see which customer placed which order by linking them through a common column, such as the customer ID. So, you all know what a join in SQL, and let's discuss its type. So join types are basically, there are 4 types of join, which is inner join, left join, right join, and full outer join as well. So what inner join will do is, it will combine rows from both tables where there is a match in the common column. Think of it as the overlapping section in the Venn diagram. Only rows that exist in both the tables are included. The left join, or we can call, or the left outer join, it will retrieve all the rows from the left table and the matching rows from the right table. Remember, the left join will retrieve all the rows from the left table and only the matching rows from the right table. If there is no match, the result includes null values for the right table's column. Think of it as including the entire left circle in the Venn diagram along with any matches in the right circle. Right join or the right outer join is similar to the left join, but it will retrieve all the rows from the right table and matching rows from the left table. If there is no match, null values are included for the left table column. Think of it as including the entire right circle in the Venn diagram along with any matches on the left circle. Then we have the full join. Full join will combine rows when there's a match in the either table. If no match is found, it includes null or the missing values from the either table. Think of it as combining both circles in the Venn diagram. Everything from both tables are included. Now let's move on to the seventh question, which is, what do you mean by a null value in SQL? It's very easy. Null value in SQL means that a column has no data. It's missing or unknown. It's not the same as an empty string or the number 0. Those represent actual value, while null represent no value at all. For example, if you have a table of customers and one of the row doesn't have a phone number, then the phone number column for that row would be null. See, we have listed this in the table here, you can see. If you do not have any data, just simply write null. So the next question is, define a unique key in SQL. So a unique key in SQL ensures that all values in a column or a combination of columns are unique. That is, no duplicates are allowed. It's like having a rule to make sure that no two rows in a table must have the same value in that column. For example, in a user table, the email column can have a unique key to ensure that no two users can register with the same email address. Remember the key points. Unlike a primary key, a table can have more than one unique key. Unique keys allow null values while primary keys do not. So these are very important to remember. So if you're asked a difference between a primary key and a unique key, just simply say that unlike primary key, a table can have more than one unique key, and unique key allows null values while primary key doesn't. So here is a table we have listed below, that is create table users, and we have given user ID as integer primary key, and then we have email varchar as a unique key. So here the email column is a unique key, so that each email must be different. It should not be the same. Now let's look at our next question, which is, what is a database? A database is an organized way to store and manage data. Think of it like a digital filing cabinet where information is neatly arranged in tables with rows and columns. Each row represents a record and each column represents a specific detail about that record. For example, a database for a library must have a table for books. Then the rows could represent individual books and the columns could include the book title, author, and the publication year. The main purpose of a database is to make it easy to store, manage, and quickly retrieve data whenever you need it. Databases are used in everything from apps and websites to banking system and e-commerce platform. Now let's look at our question number 10, which is explain the differences between SQL and NoSQL databases. So here's a simple explanation. SQL databases are structured, which means they can store in tables with rows and columns, like a spreadsheet. They follow predefined schema, meaning the structure of a data is fixed and you need to define it before adding any data. These databases are great when you need consistent and reliable data, like for banking system or inventory management. Examples are MySQL, Oracle, MS SQL, PostgreSQL, etc. And SQL databases are also known as RDBMS, which is Relational Database Management System. Let's talk about NoSQL databases. So NoSQL databases are flexible and do not use table. Instead, they can handle unstructured or semi-structured data. So NoSQL database is dynamic, where data is primarily stored in JSON objects, key value pair, graph nodes, etc. They don't have a specific structure. Such databases are mostly not preferred for performing complex query operations, and the examples include MongoDB, CouchDB, Elasticsearch, etc. So now let's move on to question number 11, which is what is a table and a field in SQL? So a table is like a spreadsheet that stores data in an organized way using rows and columns. Each table contains records and the details. For example, a table named employees could store information about employees in a company, whereas a field is a column in a table and it represents a specific attribute or property of the data. For example, in the employees table, fields could be employee ID, name, and department. So here's a simple example of the table. You can see here the fields name, or we can say column, and we also have the records or the rows, we can say that. So in this table, the entire table is called employee. Each row or record stores information about one employee, and each column or field represents specific details like employee ID, name, and the department. Now let's move on to question number 12, which is describe the select statement. Well, the select statement in SQL is used to retrieve data from a table or multiple tables. It's like asking databases, show me this specific information. Here's how it works. You can specify which columns you can see. For example, to retrieve all customer names from a customer table, you can select name from customers. If you want to retrieve all the data, just write this query, select star from customers. Remember, I told you before in the first question, we are using star if you want to retrieve all the data from the table. And if you want to just retrieve from a particular row or a column, just simply write, select name from customers, the field name. You can also apply filters. You can use the where clause to filter the results. For example, you can write select name from customers where the city name is New York. You can also sort the results. Use the order by to sort the data. For instance, to sort customers by the name, you can just write select name from customers and then order by name ASC. ASC means ascending order. So in short, the select statement lets you choose what data you want to see. Now let's talk about what is a constraint in SQL and name a few. So if you ask this question, just simply answer a constraint in SQL is a rule applied to a table that ensures the data stored is accurate and consistent. It also helps in maintaining data integrity by restricting what values can be added or modified in a table. Here are some common constraints: primary key, we have foreign key, then we also have unique key, check, not null, and default. So we have already discussed about primary key. It ensures that each row in a table has a unique identifier and the column can't contain null values. Foreign key links to a column in one table to a primary key in another table to maintain relationship. Unique key ensures all the values in a column are distinct, that is, there are no duplicates. The check ensures that data meets a specific condition before being inserted or updated. Not null ensures that a column cannot have null values. The constraints are essential for maintaining reliable and valid data in your database. Now let's talk about what is normalization in SQL. Normalization in SQL is a process which is used to organize data in a database to make it more efficient and reliable. The goal is to reduce redundancy, which is duplicate data, and ensure data consistency. This is done by splitting a large table into smaller related tables and then linking them using relationship like primary and foreign key. For example, imagine a single table that stores customer details and the orders. If the same customer places multiple orders, then their information like name and address would be repeated for each order. Now, using normalization, you would separate this into two tables. First, we would have customer table, which will store customer details like customer ID, name, and the address. And then we have order table, which will store order details like order ID, customer ID, and the order date. Now, by linking these tables using customer ID, you can also reduce duplication and ensure that any changes to customer details are updated in just one place. Now, let's talk about question number 15, which is how do you use the where clause? It's very easy. So just answer the where clause within SQL queries serves the purpose of selectively filtering rows according to a specified condition, thereby enabling you to fetch exclusive those rows that align with the criteria you define. For example, select star from employees where department is equals to HR. Now let's move on to question number 17, which is difference between union and union all. So union is used to merge the contents of two structurally compatible tables into a single combined table. The difference between union and union all is that union will omit duplicate records, whereas union all will include duplicate records. Very easy. Union will omit duplicate records and union all will include duplicate records. The performance of union all will typically be better than union since union requires the server to do the additional work of removing any duplicates. So in cases where it is certain that there are not any duplicates or where having duplicates is not a problem, then we can use union all. It would be recommended for performance. So now let's move on to the question number 18. So here a table is given below and you will have to say what will be the result of a query. The query is select star from runners where ID not in, select winner ID from races. So the answer is, given the simple data provided, the result of this query will be an empty set. So the reason for this is as follows. If the set is being evaluated by the SQL not in condition contains any value that are null, then the outer query here will return an empty set, even if there are many runner IDs that match winner IDs in the races table. Question number 19 is what are indexes in SQL? Indexes in SQL are just like having a shortcut to quickly find data in a table. Instead of searching through every row one by one, an index creates a sorted structure based on one or more columns, making data retrieval much more easier. For example, you can think of an index in a book. If you're looking for a specific topic, you can go to the index at the back and find the page number instead of flipping through every page. Similarly, in database, an index helps the system quickly locate the rows you need. So here's how it works. If you often search for customers by their name, creating an index will speed up those queries. You can just write create index IDX customer name on customer and then the customer name. The database uses the index to find the row, so you just have to run a query which is select star from customers where name is John, and then you can use the index to find the row with name is equals to John much faster. Let's move on to question number 20, which is explain group by in SQL. The group by clause in SQL group rows with the same values in a column, allowing you to apply functions like sum, count, or average to each group. For example, in a sales table to find total sales by region, you just simply have to write this query which is select region, some amount as total sales from sales group by region. So the group the sales by region and calculates the total for each. It's a quick way to summarize data by categories. So now let's talk about question number 21, which is what is an SQL alias? A SQL alias is a temporary name you can give it to a table or a column in a query to make it easy to read or work with. It's like giving a nickname to something for clarity. For example, if you have a column named first name, you can use an alias to rename it as first name in the query results. You just simply have to write this query as select first name as first name in capital letter, last name as last name from employee. Here the AS keyword assigns the alias and the output will show the columns as first name and last name. Aliases are also useful for tables. So for this, you can just write the code as select E first name from department table. So this shortens table name for easier referencing. Aliases are not permanent, they only exist while the query is running. Now let's talk about the question number 22, which is explain order by in SQL. So you can answer this question like the order by clause in SQL is used to sort the result set of a query based on one or more columns. You can specify each column sorting order, ascending or descending. For ascending, you have to use ASC, and for descending, you have to use DESC. Okay. So just have to simply write this query as select star from product order by price DESC. Now let's talk about question number 23, which is differences between where and having in SQL. The where clause is employed to restrict individual rows before they are grouped, such as when filtering rows prior to a group by operation. Conversely, the having clause is utilized to filter groups of rows after they have been grouped, like filtering groups based on aggregate values. The having clause, it cannot be used without the group clause, whereas the where clause specifies the criteria which individual records must meet the selected query. It can be used with the group by clause. Question number 24 is, what is view in SQL? One more important question. So, an SQL view is essentially a virtual table that will derive its data from the outcome of a select query. Views serve multiple purposes, including simplifying intricate queries, enhancing data security through an added layer, and enabling the presentation of targeted data subsets to users, all while keeping the underlying table structure hidden. Now let's move on to question number 25, which is, what is a stored procedure? So if you are asked this question, just simply say a SQL stored procedure comprises of pre-compiled SQL statements that can be executed together as a unified entity. These procedures are commonly used to encapsulate business logic, improve performance, and also ensure consistent data manipulation practices. That's it. Now let's move on to question number 26, which is one more important question, which is, what is triggers in SQL? A SQL trigger consists of a predefined sequence of actions that are executed automatically when a particular event occurs, such as when an insert or delete operation is performed on a table. Triggers are employed to ensure data consistency, conduct auditing, and streamline various tasks. So you can use insert trigger, update trigger, or delete trigger accordingly. Now let's talk about what are the aggregate functions, and if you know them, name a few. It's very easy to answer. Aggregate function in SQL perform calculations on a set of values and return a single result. At first, we have minimum, which will get the minimum value from the resultant set. Then we have the max function, which will give you the maximum value from the resultant set. The sum will give you the sum of values from the resultant set. Average will give you the simple average of the resultant set. And the count will count of numbers records from the resultant set. Now let's talk about question number 28, which is, how do you update a value in SQL? The update statement serves the purpose of altering pre-existing records within a table. It involves specifying the target from the update, the specific columns to be modified, and the desired new values to be applied. For example, if you want to update, you can use query like update employees, set salary is equals to 6,000, where the department is IT. Now we'll be moving on to some intermediate SQL interview question and answers. So one of the question is, what is a self-join and how would you use it? I would like to repeat again, these join types of question is very important. These are often asked in interviews. So talking about what is a self-join in SQL is a type of join where a table is joined with itself. It's useful for comparing rows with the same table or exploring hierarchical relationship, such as finding employees and the managers in an organization. So imagine if you have an employee table, so you have employee ID, name, and the manager ID. So if you want to find each employee and the manager, you can use a self-join. You can just simply write a query as select ename as employee, mname as manager, from employee, left join employees on manager. So I've already discussed with you before what is the meaning of left, right, and self-join. So here the table joined with itself using manager ID to link each employee to the manager. A self-join is helpful for comparing rows in the same table or working with hierarchical data. So now let's move on to question number 30, which is explain different types of joins with example. At first, we have inner join. The inner join will gather rows that have matching values in both the tables. Then we have the right join. It will gather all the rows from the right table and any matching rows from the left table. Left join will gather all the rows from the left table and any matching rows from the right table. And the full join will gather all rows where there is a match in either table, including unmatched rows from both the tables. Very easy. Now let's move on to question number 31, which is what is subquery, and provide it using an example. So subquery basically refers to a query that is embedded within another query, serving the purpose of fetching information that will subsequently be employed as a condition or value within the encompassing outer query. So you can just use this query, which is select name from employees, where salary is greater than select average from salary from employees. Now the next question is, how do you optimize SQL queries? So basically, the answer to this question would be something like SQL query optimization involves improving the performance of SQL queries by reducing resource usage and execution time. Strategies include using appropriate indexes, optimizing query structure, and avoiding cost operations like fully table scans. Now let's talk about question number 33, which is what are correlated subqueries? It's a type of subquery that makes reference to columns from the surrounding outer query. This subquery is executed repeatedly, once for each row being processed by the outer query, and its execution depends on the outcomes of the outer query. Now we'll be talking about what is a transaction in SQL, and it's very important. One of the most important questions asked every time in SQL interview questions. So basically, a transaction in SQL is a group of one or more SQL commands that are treated as a single unit. It ensures that all the operations in the group either succeed completely or fail entirely. This guarantees the integrity of the database. Imagine you're transferring money from your bank account to a friend's account. Then the bank first deducts the amount from your account and then it adds the same amount to your friend's account. These two steps together form a transaction. If one of these steps fails, example, the system crashes after deducting money from your account but before adding it to your friend's account, then the entire transaction is rolled back, meaning no money is transferred and the database returns to its original state. So you can also explain this question with the help of example that would be more, clear to the interviewer. Now let's talk about what are ACID properties in SQL. So basically, ACID stands for atomicity, consistency, isolation, and durability. And these are key properties that ensures database transactions are reliable and maintain data integrity. Atomicity, you can think of it as all or nothing. A transaction is a single unit of work. If any part of the transaction fails, then the entire transaction is rolled back and no changes are made to the database. For example, if you're transferring money between two accounts, either both the debit and credit operations happen or neither does. The second we're going to talk about is consistency. The database must always be in valid state. A transaction takes a database from one valid state to another, following all the rules and constraints. For example, if a transaction adds a record that violates a rule, like a duplicate primary key, then the transaction fails, keeping the database consistent. Isolation, transactions don't interfere with each other. Even if multiple transactions are running at the same time, each transaction works as if it's the only one happening. Example, if two people are updating the same record, then one transaction will wait until the other is complete. Talking about durability, once a transaction is committed, it's permanent. Even if there's a power outage or system failure, the data is saved and it won't be lost. After you complete an online purchase, the transaction is stored securely even if the server crashes immediately after. So this was for the ACID properties. And now we'll be moving on to our next question, which is how do you implement error handling in SQL? Error handling in SQL is a process to manage and respond to errors that occur during query execution. Different database systems have specific ways to handle errors. In SQL Server, the try-catch block is commonly used. The try block contains the main operation, while the catch block handles errors if they occur. For instance, in a transaction, you can use rollback in a catch block to undo changes if something goes wrong. Similarly, in Oracle, the exception block within PL SQL is used to handle errors. If an error arises, the exception block executes, rolling back the transaction and then logging the error message. By implementing error handling, you ensure that operations fail gracefully without corrupting data, making the database operations more reliable and secure. Next question, which is describe the data types in SQL. SQL supports various types of data types which define the kind of data a column can hold. These are broadly categorized into numeric, character, data type, and binary types. So we have numeric data types like integer, float, then we have character string like char, varchar. We also have Unicode character string like encat, enttext. Then we have binary, which includes binary image, date and time, which includes date and date and time. Then we also have some miscellaneous data types, which is XML and JSON. So the next question is explain normalization and denormalization. Often this question is asked in this way also, or it could be asked something like explain the difference between normalization and denormalization. So to answer this, you have to just simply explain what normalization is, which I have already discussed before. Once again, I'm saying you normalization and denormalization are ways to organize data in a database. Normalization is all about breaking big tables into smaller ones to remove duplicate data and improve accuracy. For example, instead of repeating customer details in every order, you create one table for customers and another for orders, linking them with a key. Denormalization, on the other hand, is when you combine or duplicate data to make it faster and retrieve. For instance, you might add customer details directly to the order table so that you don't need to join tables during a query. Normalization helps you space and maintain consistency, while denormalization makes data retrieval quicker depending on what the database needs. Let's move on to the next question, which is what is a clustered index? It's very easy. Just simply answer by saying that a cluster index in SQL determines the physical order of the data rows in a table. Each table can have only one clustered index, which impacts the table's storage structure. Rows in a table are physically stored in the same order as the clustered index key. Now we have next question, which is how do you prevent SQL injection? So talking about this question, SQL injection is a security risk where attackers insert harmful code into SQL queries, potentially accessing or tampering it with your database. To prevent this, you can use parameterized queries or prepare statements to handle user input safely. You can validate inputs to allow only expected values, use stored procedures to separate logic from data, limit database permission, and escape special characters. These steps help you secure that your database is free from SQL injection attacks. The next question on the list is explain the concept of database schema. In SQL, a database schema functions as a conceptual container for housing various database elements such as tables, views, indexes, and procedures. Its primary purpose is facilitate the organization and segregation of these databases elements while specifying their structure and interconnections. The next question is how is data integrity ensured in SQL? Just simply answer by saying that data integrity in SQL is ensured through various means, including constants, example, primary keys, foreign keys, check constants, normalization, transactions, and referential integrity constants as well. These mechanisms prevent invalid or inconsistent data from being stored in the database. Question number 42, which is what is an SQL injection? We have already discussed about how we can protect our data from SQL injections. So now let's discuss what is basically a SQL injection. So SQL injection in cybersecurity attack that involves insertion of malicious SQL code into applications input fields or parameters. This unauthorized action enables attackers to illicitly access a database, extract confidential information, or manipulate the data. The next question is how do we create a stored procedure? You use the create procedure statement to create a stored procedure in SQL. A stored procedure can contain SQL statements, parameters, and variables. So here's a very simple example. You can just simply create by writing this query as create procedure, get employee by ID, at employee ID integer as begin, select star from employees where employee ID is equals to at employee ID. And then you just have to write end. That's it. So next question is, what is a deadlock in SQL and how it can be prevented? One more important question often asked in interview. So you have to answer something by saying that a deadlock in SQL happens when two or more transactions are stuck because they are waiting for each other to release resources. It's just like two people trying to go through a narrow door at the same time, each refusing to step back and let the other pass. Transaction A logs table 1 and waits to access table 2. Transaction B logs table 2 and waits to access table 1. This is just a simple example. So we can see that both the transactions are waiting for each other, neither can proceed, creating a deadlock. So it's very simple, and how we can prevent this deadlock is by locking hierarchies. Always access resources in the same order so that transactions don't block each other. Timeouts. Set a time limit for transaction to wait out for the resources. You can also use deadlock detection and resolution system to detect deadlocks and cancel one transaction and let the other proceed. Now let's move on to a last question on the list, which is difference between in and exist. In basically works on list result set. It doesn't work on subqueries, creating a virtual table with multiple columns. Compares every value in the result list. Performance is comparatively slower for large result set of subquery. Whereas the exist works on virtual tables, it is used with correlated queries, exist comparison when match is found, and the performance is comparatively fast for larger result set of subquery. So guys, that's it for this video on the top 45 SQL interview question asked in SQL interviews.
And with that, we have reached to the end of this session on SQL Full Course. Should you have any queries regarding any of the topics covered in this session, or if you require assistance on the PPT or any other resources used in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to assist you at the earliest. Until next time, thank you for watching and keep learning. And also, stay tuned for more from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.